Welcome. I just realized I don't have the stream up, so I don't even know if you guys can hear me. Let's change that. Okay, you guys can hear me. Fantastic. Let's get out of here before I do something bad. Welcome everybody. Welcome. Oh, I have to make an announcement. That's right. Join the Discord. It links in the about section or description or wherever, what have you, wherever links are found. And yeah, we're gonna be doing compiler part 51, baby. Cool. And if you ask to join the notifs group when you get here, you'll be blessed with the amazing notifs role, and you'll be pinged every time I go live. You'll never miss another stream. And you can also turn on announcements, notifications for the announcements channel, whatever floats your boat. You know what I mean? Whatever floats your boat. In any case, we've made our announcement. We are live. Welcome, everybody. Welcome. We can now, I think we're just going to get started. One thing I did want to do, Skyzar says hello. One thing I did want to do is, not that. That one. Hopefully it works still. I've been changing things. But with AnnOSRS, I did want to do a little showcase of what's working just for a minute. Because we have some cool things going on. Let's get it going. So here we have QEMU. Oops, resized it. Open. Beautiful. And it works. How wonderful. And you can see we have a shell that we can type things into. Wow. It's incredible, ain't it? And what I've now done is this background built in to this shell, which means that you can actually run something and not capture its output or wait for it. It just runs in the background and then does whatever it does. So you can see we still got Blaze It printed out, but it didn't actually show up in the output of the shell because we don't care about it. So we can run now a server in the background, and it can open a socket, bind it to an address, listen so that it's actually a server socket, and then it can wait for connections to come in with accept. And then you can see accept says no waiting connections, blocking. And then we can run a client, which is another program. And you can see we've actually done it. So accepting blah, blah, blah. You can see we, in the client, we ran connect, which unblocked the server. The server then got its timeshare and started running instead of the client. So now the client runs, or the server runs, and the client blocks, at least just is sleeping in the background. You can see we accept again, we get an actual client FD, we write to it 16 bytes, and then we read. Now we're waiting until it writes because we're reading, so we need a write to the socket, until we can read from it properly. And then the client reads 16 bytes that the server wrote. The client writes 16 bytes back, and then you can see that one of them closes, so the ref count goes down, but one side's still open, so it doesn't get freed. And then you can see the client actually flushes its standard out buffer, and a bunch of stuff gets printed out that actually happened interweaved throughout all these syscalls that printed out right away. So it's a little confusing, but don't worry about that. That's what you get for concurrency, right? And then you can see we actually connect, we read, we got 16 bytes from the socket, 69 and 420. That is exactly what we wrote to it in the server. Amrect Kid, thank you so much for the follow. I appreciate it. And you can see that we actually are able to read that back in the server as well. So two-way communication. And then they both close and we delete everything. One for the server socket and one for the client socket. How about that? And then the server shuts down. So now AnnOSRS is back in a state where there's no server running, no client, and we can just be back with the regularity. Cool. That's what I've been working on. Now I'm working on an entire event system in the kernel. But I don't want to get into that because it's rough. But yeah, that's the OS. That's what I've been working on for a long time. and still will continue to do so. Now let's do the actual purpose of this stream. By the way, I totally named the stream the wrong thing. I don't think I changed it at all. Let me see if I should do that. Yeah, we're not implementing floats. We're doing compiler, BB. Okay, writing a compiler from scratch with the little tongue. How beautiful. How about that? How about that? Sorry, it says, just saw the title, my condolences, MMX registers go burr. Yo, I don't think we're working on that yet. We're not. The beautiful thing is I wouldn't even do that. I would not even do that. I would not implement hardware floats. I would implement software floats first and then slowly replace it with hardware once we get better things working. Sorry about that. Got to get that nice, crisp sugar drink because I'm American, right? There's nothing else to drink here. Let's run our tests and see what happens. Make sure nothing is broken. You can see a few failed. Looks like 3. Yep, we have 3 failures out of 86. Very cool. So that's a 97% passing rate, which is, that's POG. And it looks like the ones that are failing are the ones that have failed for a long time. We can't return arrays yet because we don't support that in the x86-64 backend. Overload block is kind of a corner case that we have to resolve the overload of an overloaded function based on the return type. So we have to pass in like an expected overload, or I don't know. We'll get there. We'll get there. I'm pretty sure we can do it. We just have to loop over like all the overloads of this and match it to the return type of the function it's being returned from. And then passing weird byte array. We have some problems with, like, if you have 11 bytes in an array, we don't actually, I think, align things properly and things go very wrong. Richtged says, what's the difference between hardware floats and software ones? Isn't it all software, not hardcore registers? So it says, also gotta make a meme real quick. Bless. Take as much time as you need. It's gonna be glorious. I'll speak on, if you check out my YouTube and the links below, I implemented floats in software. But like, yes, last week, something like that, right? Close some things. So I implemented it like last week. Where is it? Here, this library, Mantissa. I even still have it opened. Floating point in software, right? Why did that happen? What has happened? They changed it. GitHub changed it. Okay, this is interesting. The README is now in the middle. And then you can switch between. Okie doke. Okay. GitHub just changing it up on me. They're really freaking me out. Anyway, Mantissa library, floating point in software. So when you like actually add 2 numbers, this is what I mean by in software. You can implement floating points as just 32 bits because this is a binary 32 IEEE representation. And we can basically add them in such a way where we just check like all the special cases like 0, nan, infinity, etc. Negative, if you're a plus negative b is the same as a minus positive b. And then from here on, you can see we actually do the addition of the mantissas and matching up the exponents first, and then normalizing the mantissa and exponent. This isn't what happens when you have 2 floats. Here, let's see if we can do like a Godbolt thing, because you'll be able to see very well. Oh, I had some testing from the binary 32, which is pretty funny. This will be good. Can I see Where's that other window? I want to see the disassembly. I don't remember how to use this. Hopefully somebody does. We'll get there eventually. How to see the output. Well, we'll get there. First, I can probably just remove all this. And then just write a simple main and say float a equals 3.1, float b equals 4.2, float c equals a plus b. It'll return 0. That's fine. Now I just got to figure out how to actually see the disassembly in Godbolt. Sarade, I know you're making a meme, but if you can hear me, I need your help with Godbolt. How do you see the disassembly? Yeah, I don't need to know timing. Am I missing something very obvious? I feel like there's not a button here that says disassemble. I don't want to save and load anything. That should be there by default. What have you done? I don't know. Ooh, that's not good. Okay. MRectKid says he changed it. I didn't do anything, I swear. Reset code and UI layout. Can I do one of those things? Okay, that's not what I thought open a new tab meant. Diff view, oh god. Add button. Source editor. Okay, I don't need source number 2. Oh Jesus. Diff view. Okay, not that, but closer. Tree IDE mode. CMake. Oh lord. Okay. We'll get there, boys. I just want a window that disassembles. Can you please just show me a disassemble window? Where it says this thing, there's normally a menu bar. I have no idea what you've done. Well, I've broken things, it seems. Do I need to not be on trunk? No, it should be fine. I just had to check. Don't go to modules. Yeah, don't, please. Well, I'm just going to copy and paste this, and we're doing this. It worked. Pog. I don't know what I did, but I did fix it. That was amazing. All this for you, MRectKid. All this for you. We care about you here. Can I zoom in? No. Can I zoom in? I can't click even today. Okay. These are not these are not general purpose registers, as you can see. And as you can also see, there's an add happening here, but it's add SS. And if we look up add SS x86, we can see it's an add scalar single precision floating point value. You can zoom in, that's what the A button is for. Wait. This thing. Okay, beautiful. Legendary. They're separate for some reason. So yeah, it's using add SS, and it basically is a hardware instruction from Intel on x86 CPUs that adds 2 XMM registers, the bottom 32 bits as a binary 32 single precision floating point based on IEEE, and it can require SSE, AVX, or AVX512F if you happen to have them supported. You can use these more complicated forms, and I'm not sure which one we're using. It's probably the simple one, because Godbolt doesn't want to assume too much. And x86-64 requires SSE. MRectKid, aw, says I'm equally grateful. I appreciate it. And yeah. So as you can see, it all works out. You can see it's a little confusing here because they're just using the decimal number to actually represent the floating point constants, which is, I mean, that's fair, but it's quite interesting. Goaki52, first time chat. Hi, what's up, Goaki? But yeah, that's floating point. So when I mean software, I mean this craziness. This is what the hardware is doing, but we do it in software. Instead of using that add SS single instruction to just take these bits and add them, we actually do all this. And it means that we don't have to do anything with the XMM registers, which are different sizes than general purpose registers, which means that register allocation doesn't need to be a blow up in complexity. I think we should merge this today. Thank you so much, Sir Aid, by the way. I appreciate it. Because I am illiterate when it comes to Godbolt. But yeah, I think this is good to merge. It kind of grew in size. It's quite a large PR at this point. But parameters is hard. And this basically just went over actually passing parameters of like structs and arrays, things that are bigger than an integer. I think it's a good time to start getting into the code. So we have intercept here. We can load the editor file just to get ahead of ourselves. And I added some new thing, I believe, where you can reinterpret aggregates now. Yes, this is exactly it. Beautiful. So in C++, you may not know this, reinterpret cast kind of sucks. So in C++, if you have an array of like 8 chars or 8 bytes, and it's like known at compile time even, right? You can have an array of 8 bytes in C++. You can't like reinterpret cast into an integer or a size t. Why? I don't get it. Why can't you reinterpret cast into an integer? So intercept does not follow C++'s footsteps because this is a memory safe operation. So it says the reason why you can't do that is because the standard doesn't want to deal with endianness. Well, if you're doing the cast, then you should deal with endianness. But you're right. Or alignment. Well, that's the thing, we check alignment. When I say same size, I mean same size and alignment when I'm talking about types. Because we can look at the type checker and look in convertible, I believe, is where it happens. No, it's not in convertible. It's in probably the handling of cast itself. That's not the handling of cast. Okay. Yeah, this thing. How beautiful. 69,420 Lamau. If a type has compatible alignment with and a size equal to the type it is being cast to, there will be no memory errors, so why not allow it, i.e. U16.2 as U84 or U84 as S32, etc. Yeah? And then this is the code that does that, but don't worry about it. Oh, okay, only endianness then. Yes. And I think that, truthfully, it wouldn't be too hard. Everything is little in... Oh, I wish. I wish everything was little endian today. And another cool thing to point out is that with endianness, because we can do this, we can also actually do this, right? Like integer as byte 8. I know we don't have an integer, but hopefully that makes sense, right? You can have an integer and then convert it into bytes, and then you could have some operation that works on byte arrays and swaps them, right? Reverses them. And then you could have bar as integer now be swapped in endianness. And once we get size of, I don't know how we're going to do that. It may be something like this. I don't know. Because I think this is going to be a, like, and type is going to be a, I don't know, maybe hash type, something. The size of operator, right? You can just do this, and then you could very easily swap the bytes of anything in endianness. But yeah, I wish everything was little endian. It's not quite that easy. But this test passes, as you can see. And it's quite simple, because nothing actually needs to happen. It's just a bit cast, which is in the C++ standard. But yeah, that's what I've added most recently. But on top of that, we also now have references. So you can take references to things, and sorry, I wish everything was little endian networking. I'm about to ruin your day. Exactly. That's exactly what I'm picturing. Yeah, so with where to go? C-test, please. Okay, yes, I'm a professional. No, I'm not. That one. Okay. We should start working on stuff, or we should think about merging this. I think we're going to merge it. All the tests that were passing are passing. And we now have references, we can pass parameters, and everything like that. So I think we're just going to do it. As long as, Saray, do you feel good about that? This isn't like the horribleness. I think I can just click this button and have a good time. Kumar says, okay, networking is an outlier. Sorry, I'd put in the I think in there so that he has some plausible deniability. He's like, no, that was all you, man. Dun dun. Okay, now we have to do some git stuff. And that might be important. It's not. Yeah, because this has to happen. So we're just making it simpler. Yeah, this is just format, and then this is just unreachable code, because we return. If we take a look, I can show you. We return if type is struct and if type is array, and this is all within if type is array or type is struct. So one of those has to happen. There's probably a better way to do this. Yeah, we should do the size check outside of the array or struct check. And then when in here, we can just keep this. Yeah, we can literally probably just get rid of this check and it still works. We'll think about it. We'll think about it. Either way, our changes aren't important as far as it goes. So we're going to do a stash and say a not that. A mustache. Perfect, a mouse stash. Nope, it's just enter. Kumar says pointers, passing by reference requires spilling and reload, right? Then there's a potential aliasing that breaks some optimizations like auto-vectorization. What? Passing by reference requires spilling and reload? I don't know what that means. Why would you need to spill something to the stack just because you pass a pointer to it? Like you have a variable in a register and you want to pass by reference. Sorta. I don't think we could, that doesn't really make sense because the only thing you can really, like there are no registers in intercept. It's higher level than that. But So a variable is never in a register. Temporary materialization. It's where you turn an R value into an L value. We just disallow R values. We have L values. There's even a test. I think I just looked at it. There's even a test for that. References ensure L value. This is an error. I don't think references and intercept can bind to R values, right? That's exactly right. This is an error. So you can't pass a reference to 4 because what would it do? It would just change this 4? For what? It can't be extracted again, so that never happens. So if something isn't in memory already, then we don't allow a reference to it. Simple as. But there's even array references. So you can have a reference to an array of 4 integers, change the second one and return it, and this works. Okay, so you don't create temps. Not at the moment. The only temporaries that are created are the ones you see right here. And this literal gets its own spill, just because we don't do array literals at compile time yet. I don't believe, if we looked at the code output. Okay, we can now fetch, and then after we fetch, it's going to tell us this is a local branch now, so we need to branch and check out, I think just main, and then we need, because this is our local main branch, and then we need to, yeah, we have 71 unpolled, everything we just merged. How beautiful. And then we can actually just merge from origin main. And everything is good to go now. And then I think we can pop this stash. Let's see what happens. Adpex to... I'm going to call you Apex. Apex, I wish there was a compiler tag on Twitch. That's a good idea. There would be pretty much only me there. But yeah. No, there's lots of people doing stuff. I'm sure it'd be popping. Cool, so we have our little changes now. And yeah, we're ready to get going. Let's take a look at the to-do. What have we told ourselves to do? We want types as values using the AND operator. That's what I was talking about. Requires structs. We have structs now. So that's a possibility. MRectKid says petition to add it. Yeah. That's a good idea. We have early return. Ooh, and then all these types. We want signed and unsigned, explicitly sized integers. However, okay. Adding 8 keywords and 8 types when they're all effectively the same thing kind of hurts my soul. So I was thinking about trying to make like arbitrary sized integers and arbitrary signed or not signed or like that. And just have that be one type. And the type information has all the data about whether or not it's a 64-bit or 17-bit integer or signed or unsigned. And then the back end can deal with that. And on x86-64, it'll just say it only supports 8, 16, 32, or 64, which is not insane. Or we could just round up and say if you asked for 57, we'll give you an I64. We'll think about it. And then also early return. This might be one that's good to do, but it requires the return block in the IR, as far as I know. We could also just have multiple returns, but then if we ever want to do like scope cleanup, that's going to get really messy because we don't have a single place we return from, so we can't do things at the end. So having a return block would make all that easier if we ever want that, and I'm sure we do at some point. at least for something like a built-in defer. But yeah, we add multi-line comment syntax. That would be good. I believe I've done this. Oh no, so there are a lot of copies when we're copying arrays. So when we assign to A, we actually have to copy B and then copy into A from that copy of B instead of just copying B into A. It prints unknown symbol even for mismatched overload. That should have pretty error. Interesting. That is an interesting one. Change name of Linux calling convention, it's actually just system 5. That's very true. That wouldn't be too hard at all. Zero member access steal does add when it doesn't need to, as far as I know. That's something we could go look at. So when we're code genning, I'm assuming, a member access, yeah, we code gen this IR add no matter what. And then we even have a to-do here. We can just use the address of the struct with a modified type. Okay, yeah. So we need to modify the type and do this thing. But this IR add can actually be an if. And what would we like to know? If the member byte offset, do this thing. I don't think we even need that technically. And then else we can say, what is this going to equal? We can just use the address because we don't need to add anything to it. We just need to modify the type. So this is going to be a copy instruction, I believe. Does this insert? I feel like IR copy doesn't insert. It does not self-insert. Okay, so IR copy doesn't insert. So we're going to have to do that ourselves. So that's out the window. Can we insert here? Why is that not normal? Because we're in the L value-ness. So we just want to set address to a copy. So IR add self-inserts as far as I know. Let's go take a look at that. Okay, it's not here because it's a binary instruction implemented like this. Okay, and it does self-insert. Why do we not have insert? What's going on there? It's just IR insert context instruction. So let's do that. And instruction is going to be L value address, I would guess. And context is CTX, it looks like. Beautiful stuff. Okay. And this is going to be a context, and why does it need the context if it doesn't use it? Either way, what are we copying? I believe we're copying the struct address because we're trying to access a member of a struct. So we need the address of the struct. Yeah, we just need the left-hand side of this thing. And the reason we need to copy here is so that we can modify its type without modifying the struct's type. It's a little messy, but I think that's fine. Let's take a look at that. Run our tests, see what breaks. Okay, it looks like things didn't break, so that's good. So let's look at the code. Let's look at the code of a member access. Do I have an example? We do have a member access example. How beautiful. So let's look at this X member access. We can do that with something like this. It's an example. And perfect. And then I guess we could look at the IR. Before lowering, we can see that we have in the AST member access of X on a vec2. And that corresponds to, let's find it. So when we load 13, that's from an add for 12.8, load 10. So this is the actual loading. Ah, yes. Here it is. So you can see that this vec2, which has an x and a y integer, you can see that it actually gets copied here, but it gets copied as a pointer to an integer, not as a pointer to a vec2. And this means that we have now basically selected the first member just by changing the type of the pointer that it is, right? So then when we load this, we actually get an integer by itself because we just dereference it one time. So now we load 10, and this gets us the first integer. Whereas before, we were adding 0, which we can, I guess, probably check. Because if we never do any of this, just these few lines, we can take a look. And yeah, look. So now you can see it's longer, first of all. Second of all, you can see that basically before, when we copied number 4, we no longer do that, and we're actually adding to 4 9, and that becomes a pointer to integer. And 9 is actually 8. I'm off by 1. I'm down here. Add 4 and 11. So you can see we add 11 to 4, and 11, this instruction, is actually just 0. So we're adding 0 to it, even though we don't need to. And that gets transferred all the way out to the output, as you can see. So when we have that add for 11 somewhere, oh, all the numbers changed after lowering. So after lowering, where's that add? Add 6, 16, okay. This thing. You can see that we add racks in RCX, but in RCX we just have 0. Right? So we're just adding to 0 for no reason, and this is actually going all the way through to the hardware, or to the binary. And after we change these few lines, you can see that we can recompile. Code.s will change once more. And you can see that we now no longer have those adds. We have a copy, so we move it to a new thing, and then we just load the 0 byte offset of it directly without doing any of the add or the load of the 0 immediate or anything like that. So we just did a very good portion of optimization just for accessing the first member of a struct, which I guess now is technically more efficient than accessing any other member, which is kind of interesting. So we can now check that off in the to-do as an optimization. How about that? And we can to-done that. Beautiful stuff. And we can say cogen 0 offset member access no longer adds. That's good enough for me. We'll give that a push. How beautiful, how beautiful. Okie doke. By the way, if there's any white lines around this chat, please tell me as soon as possible. I tried to double check today, but the problem is I can't look at the preview in full screen. So if it's literally 1 pixel, I might not see it just because it's shrunk down a little. Because OBS doesn't actually let me go absolutely full screen with the preview. Or at least I don't know how. That's good. We did it to do. How beautiful. Attributes. Okay, attributes are difficult. Attributes are difficult just in their parsing. Because we kind of have to build something up for something that we don't know yet. Does that make any sense? So if we think about how attributes might work, like attribute no mangle, maybe it looks like this, right? Or maybe it looks like this, or something like that. Something, right? Let's say it looks like this, attribute no mangle. What if we want to also have another attribute? And then, what if we have like export? What does export go after the attributes or before it? And if it goes before it, that means that we have to be able to parse attributes in the middle of an expression, which just seems bad. So I've been trying to think about how attributes work. And let's say you say, okay, export goes first, and then the attribute, or export goes closest to the thing. They have to be next to each other. But in that case, you still have the thing where it's like you might have multiple attributes up here, and you still just are parsing, okay, we got an attribute, okay, we got an attribute. But you don't actually know what they apply to yet when you're parsing, because we haven't parsed all of this. And only once we parse all of this will it make sense. Which is why I'm a little scared about attributes, right? It seems a little funky. I've also thought about putting attributes somewhere else, but I don't feel like there's a good place to put them in this syntax. That doesn't make it kind of weird. Like, even if we put it here and said, okay, you actually just put in a attribute here, and then you can say no mangle, blah, 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 right? This kind of looks very odd, where it's like foo integer attribute no mangle equals 69. Like, no mangle equals 6, that doesn't make any sense. We want the integer function to actually return 69, but then we also want the attribute to apply to it. Hopefully that makes any sort of sense. But yeah. So if we let's just think about how we would parse this. So if we get attribute as a keyword, we could obviously then parse one. A keyword can become any token. So then we'd have like a token attribute followed by a token identifier, this thing. I'm just thinking, if we have, for example, like align as requires an argument, right? You need to give it a number, like I want you to align it as something. It doesn't make sense for a function, don't worry about that. Imagine this is now a type. But if we want align as, it needs to have a thing. And what this means is that we'd have to parse the identifier that we get after. But then in lexing, see, we would just get an identifier and then a left paren and then a... So when we're parsing, we'd have to like expect the left paren after checking that the identifier is the right thing. We'd have like a subset of keywords, which are attributes. And then those are all parsed differently. Is that insane? Maybe that's not too insane. The second thing is how to... Mrect Kid says yes. And then, so I just don't know the alternative. So let's say we parse attribute as a new keyword. When we're actually handling things and parsing them, wherever that is, here, right? Like, cool, we get the keyword. What are we actually looking for? So when we get a 4, right, we try and get a bunch of expressions in a row. And then make a 4 at the very end. The other thing, how do attributes actually get attached to the coming expression? Because we're going to parse an attribute, but that's not an expression. But the expression that we parse needs to contain that attribute, right? So when we actually, in the node, we need somewhere to actually have an attribute. Or we need to have like a bit here. But we can have any amount of attributes, and some of the attributes have data attached to them. You know, this is hard. Attributes are a hard thing, because I wonder if Suraid knows anything about this. I wonder if, which part of it am I overcomplicating? Suraid says, Attributes. Attributes are really hard. I'm just trying to think about it. We can't like have flags for each attribute because some attributes require data, like align as. So somehow we need to be able to first of all parse like, oh, align as, and then a number, right? So we need to actually be able to like parse attribute as a keyword, parse the attribute that we're actually have here, right? Make sure it's a valid attribute. And then some attributes will require data, like a 16, and this has to be stored somewhere. Attributes are generally only allowed on declarations, so that makes them easier to parse. But sure, some attributes have arguments. Right, so first of all, we're going to parse this. Where does the 16 get stored? Like when we're parsing, where does the 16 get stored? And then where does it get stored in the AST, in the node? Like, do we have to add a linked list of attributes and then just have it be like sitting around here? That seems like way overcomplicated for what I want to accomplish. Align as only makes sense on types and variable decals. Yes. But we don't know when we parse attribute, the attribute keyword, whether there's about to be a type or a variable declaration or anything. We have no clue what's coming next. We just get an attribute. Because like, because what we're gonna have to do is like, oh, case token attribute, you know what I mean? And then handle it. That's why I put them after the declaration. Even with functions, that looks crazy, dog. Like, where would you put them here? Like, let's say you put them here. That doesn't look right. But yeah, this way you'd have to parse the attribute first, then call parse decal, and then apply the attribute. I see. Okay, that's making more sense. And then when you say apply the attribute, what is an attribute? Where does it get stored? Are we going to have like in AST, we're going to have like a linked list of attributes in the thing? Rotate the thing. Like, do we just have attributes here? And then that's like a linked list of attributes. Add an attribute nomangle member to functions. So each thing that responds to an attribute will store the appropriate member in its node value. is what you're saying. What about this? Because a struct declaration might be aligned, might have an align as. So is this no longer going to be a type def symbol? Or are we going to have a symbol and some member list of member? This seems messy. Everything's split up all over the place. Because like in function, we're going to have like pool export. Like there's going to be a lot here. Am I right? There's going to be no mangle. There's going to there's going to be a lot. Well, either you do it this way or you do it the Clang way. What's the Clang way? I'll hear it out. It's Super Matrix. Thank you so much for the follow. I really appreciate it. Thank you so much for being part of our exclusive community. Very hard to get into. Let's think about this. What does this syntax truly want to be? That's horrible. So I feel like we shouldn't separate this, because this is kind of the declaration syntax. So if we were to put it after the declaration, it would go here. Which is a mess. Right? Is this readable? I don't feel like this is very readable or understandable. And let's say it's not a one-liner, right? Even if it's not a one-liner. Or it is, but just with braces. Is this acceptable? How does chat feel about this? You can look at the format check plugin. It registers an attribute. Each attribute is a separate struct, and each AST node can store arbitrary attributes. Okay, that sounds right. That sounds like what I was thinking. But then the trouble becomes, okay, so I see the argument. If they're only ever really allowed in declarations, why not just put them in here and access them very easily whenever you have your declaration? Extern proc printf u8 pointer variadic, where variadic is an attribute. And type func has an attribute variadic member. Right, all of our type attributes could also, or types could also gain this same type of thing. So what if we dropped the attribute? So how does that work? So you can no longer in the parser consume I'm trying to think about this. So after we parse the type, then we have to parse attributes. So in here, if we parse as many attributes as possible, is that the thing? Is this the answer? No mangle would be a contextual keyword here, as is variadic in source. So you're saying if we're parsing a declaration, it happens to be a function, then we look for attributes here. After the argument list is where they go in the grammar here. Yes. which is after we parse the entire function type. So you're saying that it's actually going to be unique to each type kind. And we basically would just have nomangle is a contextual keyword here, which means that we would basically just check if ptalk type is an identifier. Does it equal nomangle? If so, set the nomangle attribute boolean within the function type, not even within the function type, within the declaration that we haven't created yet. This thing down here, we have to somehow affect that from up here. But yes. I wouldn't put it here, but rather where we parse the argument list. So you're saying, but in parse type, the type isn't nomangled, it's the function that we're declaring. You know what I mean? Integer has nothing to do here with nomangle. It has nomangle has everything to do with foo. Which is why I want to put it closer to foo. But I feel like just making it a keyword kind of makes things very bad. I mean, I guess they can be keywords, but then we'd have to parse an expression, and then the trouble is we might parse an attribute that parses an attribute. And what do we do then? Because this is just going to see this. It's going to be, I don't know what I got. I don't like it. I don't see a good solution that I like, though, so that's another issue. And this also means, by the way, that if we have, like, let's just look at vec2 or whatever it is. Where does this go on a type? Like, type a line as 16, that's not bad. Something ugly like attribute, C++ moment, or 2 something like foo, which we can't do. I mean, we can't do that syntax, but I guess we could do something like it. But even if the syntax, we do the syntax, and we can parse it, even if we get to there, it's still confusing, like, it's just troublesome, is what I'm gonna say. Do you forget, Sarade, you are forgetting about something. Remember that test we just looked at? What was it? The reinterpret aggregate? Yeah, remember this thing? And this thing? And what is this thing? It's an array literal, right? Oh yeah, it uses bracket for array literals, not braces. Because that's a block expression. A block expression with this in it would just return 0. But you're right, this language is a little funky in that way. Okay, so let's say that after we parse this thing, see, yeah, it's just the issue that we kind of have a chicken and egg a little bit problem, where we have an attribute, but we don't know where to put it, or we know where to put it, but we don't have an attribute. So it says, I'm going to go back to working on the meme. This is too complicated for me. All right, you take your time on that meme. I'm interested in it. You're like, man, who's the Greek guy that did it? I don't want to say a name because I'm going to be wrong. You're like a Greek sculptor carving a marble statue. It's going to be amazing. It's going to take years, but it's going to be amazing. Best of luck. Well, we now know the answer. which is that attributes are so hard, even Sarade gets scared. But not just attributes as a problem. He knows how to solve it. It's just that this language has a bunch of arbitrary limitations that are really annoying because of its syntax. So, you know, that's fun. So let's just think about where we're parsing an attribute, right? Let's say we're going to go with this syntax. This is a declaration, but this is actually a declaration because I'm pretty sure that's how we're parsing things with decl rest because yeah. You can see if it's a function and it's not external, then we parse the function body. Yeah. So when we parse the function body, before we do that, we want to parse this thing. After we parse the type, before we parse the body. And then I'm also kind of curious how a lambda happens. Parse type expression. So something that starts with a type. If this is a function type, then this is a lambda expression. Otherwise, this is an error. To do struct literals. Yep, that is a to do. If this is, then this is a lambda expression. Create a function for the lambda. And we make function after parsing function body. So what if at the beginning of parse function body is where we do the attributes? Huh. Yeet equals if found. That's right. Push a new scope for the body and parameters. Create a declaration for each parameter. Parse the body. Which is going to be a block expression or something. So yeet equals if found. We want to do before that. So right here is where we would want to parse attributes if we were to go with this syntax. Scratch that. That's where we'd have to parse it. Sword says, nah, syntax is hard. Bless. I appreciate that, Sarade. It makes me feel less stupid to know that everybody struggles with this stuff, even though it seems so simple. Like, what do you mean? Just add in a word. It's like, well, there's a whole system it has to work into here. So when we parse a function body, what do we actually have? We have the type function type. We have the parameter decals. Why do we have the parameter decals? Okay, so that's something we're just filling as far as I know. Yeah, so we just fill, that's an out param. That's good to know. So param decals is an out list of all the parameters. Function type. I wonder if the type should hold that it's no mangle or not. It kind of hurts my head. I don't know if I like that. So the problem with parse function body collecting the attributes is that in a lambda, right? This function, AST make function. Do we also do that for a non-lambda the other time we call parse function body? We do call AST make function. And we call it with type, with body. This is kind of a mess. So what if we attach the attributes to like the body node and then somehow in AST make function we go well, then what if the body actually has its own attributes? Yeah. Ow. Okay. we could add yet another parameter, an out parameter, to parse function body that returns the attributes that it parses. That's kind of a mess, but that is a possibility. That may kind of be the best thing here if we're not going to store it in the type. Let's just look at the type. So type function, we have the return type and the parameters. Now, the thing I'm having trouble with is that nomangle should only apply to one declaration. So applying it to the type would kind of be bad, because let's say we have a type integer function. This is t1, right? The problem is, if we have foo t1 nomangle, but then we have bar t1 with no nomangle, right? No attributes. We don't want this bar to be nomangled because it can be. There's no reason it can't be. There's no nomangle, so we should just be able to have that work, right? So attaching it to the type, this is why I don't want to do that. But we could store it in the, well, we don't know what we're parsing in between. So I don't want to like put it here, because then when we're parsing the body, the function type, so that'd be a problem if we were doing this, right? And then we had like bar t1, because then t1 would still be nomangled. So we can't do that. There's not really a lot of options. Not really a lot of options. I think we are just going to have to add an attributes list as an out param to parse function body. But then there's another place where attributes may go. Where's parse type implemented? Okay. There's another place where attributes may go, which is that, not this. A structure type definition, right? So after token type, then we consume a left brace and start getting members. But in between here, right, we need to collect attributes for this type. And these actually do need to go in the type, which we don't have yet. Of course. But yeah, so that's going to be needed. That's going to be needed. So we have to collect attributes for this type, and we'll make that a to-do. Because this is the little vec2 example. If we had like align as 16 here. And then up where we handled parse function body, we also want in here collect attributes and return them through an out parameter. Okay, so now we just have to think about the fact that attributes live separately from the thing. So we need to have like something that defines an attribute and maybe stores its data, right? Otherwise, what are we going to be returning through the out parameter here? It wouldn't make any sense. And the only other alternative would be to like, yeah, I don't know what the other alternative would be. We could, I guess, instead of doing this when we call parse function body, instead of doing it in here, we could do it here and say parse attributes. First of all, that's going to make all the places that make functions in the syntax have to parse attributes for functions, even though they're all going to be the same attributes. So code duplication, A little bit of a code smelt, knowing that that's not the right thing to do, right? Second of all, if we were to parse the attributes here and then apply them to this func, right? Because func AST make function will actually have the proper function type, and then we can apply the attributes into this value struct, right? And doing that, you can see that whether they're collected here or returned from in here, it's going to kind of be the same. Okay, well, let's add in attributes. I don't really know how this is going to work. I guess enums, there's a section for them. Sorry, I'd put this here, so we'll add to the fancy enum section. Symbol kind. Types of attributes, I guess. Why not? Attribute kind. This isn't C++, but it's fine. In attribute kind, we're going to have an attribute nomangle and an attribute align as. That's kind of what we know so far. And then we're also going to have an attribute count, the maximum amount. That way, if we want to loop over all the attributes, we can. All the attribute types, or kinds, I should say. So now, to actually make an attribute, we have AST nodes. So we're going to do this above AST nodes, and we're going to say, yeah, we'll just copy this little styling, say attributes. And we're going to say that we have a struct called an attribute. And this is basically just going to be, what is this going to be? It's going to be an attribute kind, which has kind. Are you mad? Enum. Yes, of course. And then we're going to have a union, and this is just going to be values. I think we have, do we use integer t? We use usize. Okay. Usize, integer. And then we can have this be not an anonymous union. That way we have to do value dot something to know that we are accessing something of the sort. If anybody has any questions, let me know. Otherwise, I think we're going to get started. Trying to parse some attributes. Oh, one more thing is that we need, where did we do nodes? Where did we define nodes? Wherever that is, I also want to have attributes. We don't know what an attribute is yet. And we don't necessarily need to. So, I know this is a little funky, but we have a little macro to make ourselves a vector of a certain type. So this should give us an attribute pointer. So we can make a new attribute and then add it and remove it from this. I think this is how we'll do it. It's kind of messy. And then let's just make a right away attribute nomangle. And then we're going to say, what do we call it? What are all the functions called? Are they make? AST make. So we're going to call it attribute make. Attribute make nomangle. It's going to return an attribute. I think this can just be a vector of straight up values. I don't think we need to do anything heap allocated or crazy, doubly nested. And we can just return out and attribute out dot company mode out dot kind is equal to attribute nomangle out dot value dot integer equal. We don't need to set value at all. We won't pay attention to it. So this should make a nomangle attribute. That should make a nomangle attribute. We are going to have to move all these to the .c file, I know. And then let's do a make align as. And then this is going to take in an usize alignment. Whoops. Alignment. There we go. Out dot value dot integer equals alignment. Return out. How beautiful. Some factory functions. Now let's think about attribute destroy all. And this is going to take in attributes pointer, I guess. We don't need a pointer to a vector. We can just take in the vector, I think. Because we're changing the, well, we'll take a pointer. And this is a tribs. And then the idea is that, well, I guess if we're destroying all of them, if they're just in the vector, we don't actually need to do anything other than free the vector. So we don't need to do anything because we'll just free the vector like we regularly do for vectors. Okay. So I think I talked about parse function body. So now I want to do the same thing. We have a nodes pointer. I want to have an attributes. Oh, wow. An attributes pointer, a tribs. And then everywhere we call this, we're going to have attributes, a tribs. Very important to zero initialize. And the other place that we do that, here. And now we should have all these attributes being able to at least happen. So in parse function body now, I'm going to say if p talk.type equals token ident, then where do we do keywords? This type of thing. Yep, this type of thing. Had to check. I was like, what am I looking at? Hold on. To do. Okay, now hear me out. So we have keywords, which if we go find keywords, we can, I think, copy this. We have span keyword and then token type. Let's just think about it. So we have a way to loop over all of these. These are spans technically, so that would be fine because we can create spans from raw, and then we can do ptalk text. Don't have go to done. Yeah, okay, I'm starting to get it now. So we're gonna say we have some struct here. This is gonna be a little weird, I think, but well, go with me. Some anonymous struct here. And this is going to be function attributes, right? And then this is going to be a span. It's going to be an array of this struct, and then, yeah. This is going to be a span, which is going to say attribute name. And I think that's actually all we need. We don't need data because I can just do this, I believe. We can make a span from a literal, and we're gonna add no mangle. And then when we see keywords, we're gonna replace that function attributes. Yeah? Okay. So we're gonna say if p equals token type indent, here's all of our attributes. Do I put static here or here? Static structive unnamed. I think I put it here. Well, no, because I'd do a static anonymous. This is the type. Yeah. Okay, messy. So this is our span for our function attribute, and we would like to check the attribute name if it's equal to the text, and if it is, so we're gonna kind of have to do a found thing here. Well, no, that's not true, because we're gonna have to do this whole thing. Oh man, this is kind of a mess. So we're gonna have to parse all of these function attributes. We could also just make this a function and call it wherever. That's not a bad idea. Okay, let's remove this. I'm kind of stumbling through the dark here by myself, but I'll get there. So we found an attribute. But if we get, okay, yeah, that's why I needed found. I'm starting to get it now. So if we loop through all of these function attributes, right? And none of them are actually equal, which means found would be false, then that's an error because we just have a random identifier where we're expecting a function body. And we can actually do that with error and then just say where and what's going on. So we have an error because there's an unexpected identifier when parsing function body. And then I think we can print that thing. Do we need /n? I don't think we need /n. And what is this thing, this identifier? I think we can actually do this and do ptalk text in this way. Because if I remember correctly, yep, it's a string buffer, which we should be able to print with capital S as well. Otherwise, we found an attribute, but there may be more. So we want to do all of this while token type is equal to ident. While token type does not equal. See, there's no delimiter here. That's a little confusing as well. So we're just going to say while it's an identifier, then do next token. This is kind of crazy. So again, what we're talking about here. So we're parsing a declaration, and then we've got to this declaration. We know it's a function. Now we want to parse the function body. And the body may start with an attribute. So we get this identifier as our first token. We go, oh, well, while it's an identifier, go ahead and parse them. And then we also need to figure out what attribute we got. So let's have span attribute name and then attribute value. This will just be the default value. Sure, why not? And also, we don't really need attrib everywhere. We kind of know that we're talking about attributes. And then this is going to have to be a compound literal. Is this a compound literal? Something like that. With an attribute, which is going to need attribute no mangle. And then the union is just 0. I know that's a little messy, but so an attribute is here, right? Maybe that's easier. Because we have this attribute and then this whole struct, which is a named attribute, effectively, right? Kind of crazy that I'm doing this, but not too bad. And then what can we do? We can push the attribute. I think we should just store the attribute type here, or the kind is what I called it. Because we may have to do more parsing for the rest. Truthfully. Must use enum, okay. Hopefully I'm making sense there. So we found an attribute, but there may be more. Keep going. If the attribute requires an argument / data to go along with it, parse that here. I think that makes sense. No mangle does not, so we don't have to do anything like that, but hey. And then, before we get to the end, we would like to do a vector push onto the attribs vector with a brand new element. Right, which is going to be equal to whatever attribute type we got. Let's just make it, oh. What just happened? Emacs just like showed me a bunch of nonsense. It flashed the screen with like gibberish and it froze for a little bit. That was insane. New attribute is going to have the attribute kind and then this attribute value as well, which is going to happen here. Yeah. That's good. Parse that here. And then we add the new attribute to this list. Are you mad? Member reference type attributes is a pointer. Did you mean to use? Ah, yes. We want to add to the vector we're pointing to. That's a good point. Well, that's a bit of a mess. So collect attributes and return them through an out parameter. Why is attribute kind not happy? Oh, I'll always forget. I really should just add a type def. Let's just go do that. Much better. Okay. Not found, unexpected dynamo when parsing function body, blah. I really wish we could put a source location. It automatically gives the token source location, wherever this is, so that's perfect. New attribute is going to be the attribute kind, which is going to be function attributes at i.kind. And we could actually use that as our found. If attribute kind equals attribute count still, then guess what? That's a problem. We found an attribute. Add it to the list. Add it to the list. There may be more, so we keep going. Okay. Did I break just... Yes, I did. Oh yeah, remember when I said I'm gonna have to move these and then I didn't? These things go here. Perfect. Okay, we can still like run the compiler. How are our tests doing? Did I ruin everything? I ruined something. The following name given to add test is invalid if CMP0110 is not set or set to old. So the CMake policy... Normally they name them for you. Add test can now officially create tests with white space, and before that was not allowed. The old behavior is to still prevent handle white space if not using mention word. And the new behavior... Interesting. So it's this. So we could set the CMake policy, or we could just fix... Oh. Emacs. That's an Emacs backup file, because this is modified. So if I just unmodify this... Whoops. We should be able to run it now, because Emacs will get rid of the backup file. Because it even saves your modifications to a file. I've broken some things. Error, unexpected identifier when parsing function body, ref. Interesting. So this kind of goes hand in hand, I see, with one of those things in the to-do I saw. Where is that? Aha. Function bodies must be blocks or preceded by equals. Guess what? Why these are failing? This is a function body that is not a block, and it is not preceded by equals, which causes big problems in this grammar, which we realized at some point. I think Sir 8 added that, and he told me about it. I was like, maybe, I don't see it. But I'm now seeing exactly why it's an issue. An interesting thing would be to not have this be an error and just allow it, and if we don't want to do this extra to do. Let's try that. Right? So if we didn't find an attribute, break. Don't do anything else. Just stop looking for identifiers and attributes and move on with your life. Hey, I fixed it. Cool. So fix me if there is an identifier following a function declaration. I should say preceding a function body. Yeah, if there's an identifier preceding a function body that is not an attribute applicable to functions, then it's kind of a problem. Yeah. If there is an identifier preceding a function body that is not an attribute applicable to functions, that should probably be an error to have the syntax be slightly stricter and catch invalid attributes in a more user-friendly manner. They'll get an invalid function attribute error instead of an invalid unknown symbol on the thing. I don't know. But it also may not. Here's what I'll do. That should probably be an error if we go through with the function bodies must be blocks or preceded by equal thing. Perfect. That's at least understandable. Why do you do this to me, Emacs? Thank you. Back to tree sitter. Thank you very much. Okay. So that can be a thing eventually, right? That's fine. Oh, I went to C++ mode, lol. Wrong one. Perfect. If the attribute requires an argument or data to go along with it, parse that here. That's exactly what we want to do. Mm-hmm. And this is going to happen here. Why not? It really just matters that this is after this. It doesn't really matter when after that. So this yeet the attribute identifier. That gave us the attribute kind. Create a new attribute. Do this thing here. That makes more sense. Function attributes. Yeah. And then when we parse the function body, not for a lambda, but for an actual function, can we now print out hello? I feel like, is it just called for each? We did just call it for each. For each attribute, atcher in attribs, please print the kind and the value of the integer for funsies. I think that's z. I don't remember. And a new line, of course, and then do attribute. We get a reference to it, which means it's a pointer, attribute kind, attribute value, integer. And then we actually want to specifically, let's try out the nomangle. Okay, well, it compiled. Oh, and it worked. Kind 0, integer value 0. And as far as we know, that's proper because attribute nomangle is 0. We may want to have 0 be invalid, but we'll see. It's fine for now. That way, when we do create a new attribute, we don't have to use token count the way we did. Well, we're getting attributes, so that's good. So we need to say for each attribute. We could also just add this to make function, but we'll think about this. So for each attribute, nomangle. So we just need to add nomangle into node function. right? Something like that. This is a bit field, if you don't know. So now we can say I think we have static assert. We do. I would like to static assert attribute count is equal to 3. Exhaustive handling of attribute of function attribute types. It's 2. Okay. So we're gonna switch, we'll switch on attribute kind. Is attribute no mangle, and then the default is actually going to be an error. Attribute cannot be applied to function. And then we're just going to give it the kind. And we can add a to-do here. Actually print out the attribute string or something like that. That way it's not just a random number. In any case, we can now do this. And in the case of no mangle, function no mangle equals true. Woo! Molly the man, hello. How's it going, Molly? What's going on? So good to have you. Welcome, welcome. We are working on adding attributes for funsies because it's something hard that I've been putting off for a long time. Well, we still get through. How about that? I believe if we take a look at the the generated code.s, we'll see the issue. Foo is still mangled. Bit of a problem. EST make function reference. Interesting. Yeah, that's just because the function itself returns. Yeah. That way you can call an immediately defined or an immediately declared function. Moldy the man says nothing much. I was trying to learn OpenGL, but I'm still bad at it. Me too. And I've written a text editor in it. OpenGL is just not easy. It does get easier as you go. There is a certain point where you start to understand the whole pipeline of like, oh, this is a layout in the shaders, and then I can change this vertex attribute layout, and it has to match in the shaders because this is basically just a struct, and then it starts to get better. It's just rough. It is rough. There's a bunch of new words. There's a bunch of new stuff. It's rough. Okay, so we have the no mangle attribute. How fun is that? How fun is that? Now we have to figure out how to make it actually work. So we create an IR func ref. And in CodeGen, x8664 is actually where this mangling happens. So you can see that if function is extern, then we don't mangle it. But I think we're going to change how that works. And we're going to have an actual bool attribute no mangle. Right? That's what's going to be checked for in CodeGen. If not no mangle. That's hurting my brain. If mangle. Yeah, so here's the thing. This is going to be if not no mangle. But not no is a double negative, so we can actually just remove those. So this is if mangle. So I think that works. Don't mangle main. That's fair. We can also just set main as a function when we create it. Where do we create main? Create the main function. We're just going to set no mangle on this bad boy, right? Why not? So we get the main type. Where's the actual main AST make function? IR function. Here it is. How about that? And we can get rid of the string equal. Why is this? Oh, it's just part of the same line. Yeah. If not no mangle, mangle. Cool. Moldy the man. Molly the man, can you show me a simple for loop that loops through names in your language? Yeah. That's a fun example. Here's one that loops over integers. If you're curious about that. Looping over names would be very similar. It'd be slightly different. We would have an array, right, names, and this would be like a byte pointer array, right? So let's say there's 4 names, and then we can actually, I think, even do this. Let's just get 2 names. We'll have Lenzer, Molly. And then we want a byte pointer, right? So this byte pointer is for name, which is a byte pointer, equal to names at 0, as far as I know. This is actually going to be a byte pointer as far as I know, actually. Name is going to be less than names at 2. And then less than or equal to names at 1, I should say. And then each time name is going to be equal to name plus 1. I don't know if this works yet because of pointer arithmetic, but we will see. We may need to add the size of a byte pointer here manually. And then ideally we could, like, you know, oots string. We can call boots name. Wait, byte is a char. Yeah. Byte is just an unsigned char. It's pretty much the same thing. What are we looking at here? 4C style. Hopefully it doesn't crash. Yeah, so this is, as you can see, or can't see, the binary operator plus with the pointer type on the left-hand side. We don't have that handled yet, I don't believe. But there was a for loop with arrays that we did do at some point. I just can't remember what they actually are. So, but yeah, we are able to do something like this. We're working on it. Molly. Molly says the syntax is so beautiful. Thank you. I appreciate that. I'm trying to keep it simple and free of like sigils and crazy stuff. There's just so many languages that just put up with stuff that doesn't. Moldy the man says it's harder than assembly. Is the syntax really that confusing? It doesn't seem too bad. The for loops aren't how they're going to end up. Eventually this for loop will be written like this. For name and names. Or name and names 0, names 2. You know what I mean? So we're going to have like range-based for loops that are much easier to write, and Molly says just make it name names. Well, that will work, but we also want to support things like doing this, where we can iterate backwards over an array, and we can iterate over different numbers. So the idea as well is that, like you said, we should just be able to put that there as well, and stuff like that. But this isn't easy. You know what I mean? I still have to get this one working, and then that way we can have this one compile into something that looks like this. Electri says similar to Rust. Yeah, sure. If you take away the borrow checker and the LLVM dependency and the entire community, yeah, it's a lot like Rust. Why do you need to say pointer to byte? Why do you have to have a const char pointer in C? Why not just at byte? Eletri says syntax-wise, lol. I see what you're saying. I guess. Maybe. Why not just at byte? Well, because you can have a pointer to an array. So if you did this, the precedence actually does something like this, right? If you just write A is a byte array, that's equal to an array of an array of byte pointers, right? It's not that. It's an array of bytes, 2 bytes, but it's actually a pointer to an array of 2 bytes. Whereas if we put around this little guy, then this is actually an array of 2 pointers to byte. It has to do with precedence, because this one, right, is equal to, yeah, like this. So to, Multi-the-Man says still harder than assembly, lol. It's definitely not, I promise you. There are plenty of examples for this language that are much simpler. Like you can look at the greatest common denominator. Oh, that's the IR one. The greatest common denominator. Very simple, right? If A equals B, return A. Else, if A is less than or equal, or if A is less than B, do GCD Euclid of A, B minus A. And this is literally just Euclid's formula. Only the man says, I'm just joking. I see. See, I never know if people are joking because this syntax may be horrible, and I have a little bit like, what if it is just unreadable and I'm insane? Sorry, it says, all right, the meme is done. Oh, you spent a long time on that meme. It's gonna be a good one. It's just gonna be like a picture of the poop emoji, isn't it? Okay, so hopefully mangling is fine, by the way. I didn't test. Yeah, main isn't being mangled. Swade says it's an off topic. Oh, be sure to check out the Discord if you haven't already. Made a new meme, spoiler. Oh, the suspense. The suspense. Dun dun. I'm just gonna open it. Stop using floats. Binary data was not supposed to have decimal parts. That's ignoring binary decimals, but yes. Years of compiler development, yet no real-world use found for anything other than char and int. I mean, kind of true. Kind of true, other than dealing with hardware. Wanted to use decimal numbers anyway for a laugh? We had a tool for that. It was called fixed point arithmetic. Honestly, fixed point arithmetic is way better than floating point in so many scenarios. And it's faster. X is equal to X can be false. 1 over 0 is a number. The sum of 1 over 10 and 2 over 10 is 3.0000004. Statements dreamt up by the utterly deranged. I like how deranged is capitalized, like they're a god or something. Look at what floating point numbers have been demanding your respect for all this time, with all the circuits and data types we built for them. This is real floating point arithmetic done by real computers. You have the Doom, the Quake 3 fucking fast inverse square root next to some cursed T-byte. I don't even know what this is. I don't even know what Fstpa, fulda Fstpa do. Or Eucmista. What is Eucmista? This is really good. Stop using floats. Oh, my cheeks hurt. I love 1/0 as a number. That's so cursed. Don't forget to scroll down. There's more? I thought that was the end. I thought that was the end. Oh no. Hello, I want to know if f is a real number and less than -1, please. Sure, that'll be f does not equal f. Oh no. Oh no. What am I looking at? F, so if f does not equal f, then it's 0. What? Otherwise it's -1 over 0 point f is equal to f, so the inverse. Moldy the Man says, how can you read this? Barely. Or, so this ternary expression, or if f is equal to -1.f over 0, then return 0. Otherwise, it's -1.f is greater than f. They have played us for absolute fools. So you're checking if -1 over 0.f? I don't even know what 0.f is. King Buns, this meme saved my life. Wow. This meme saved my life. How powerful, how powerful. Oh god. Now when do we create a node function? Node function. See, how is there already IR for the function? When was the function actually created? Was it created at parse time? If I see IR function in this file. Okay, I was about to freak out. When is this node function actually handled then? It's handled here. Okay, in IR function. And we're going to say if beautiful stuff. Zero.f is 0, but as a float. Ah, okay. I see what you're doing now. The confusing thing is you've named the variable f. F just checks if f is nan. F does not equal f because nan does not equal nan, of course. 1 over 0.f is infinity. Add a minus and get negative infinity, so that's just testing if it's plus or minus infinity. Yes, that was on purpose. Okay. It's very confusing. It's beautiful. Did you come up with that? If you did, I can see why it took you like an hour, because Jesus, that was rough. Pog, I think it worked. Oh, it worked. We have function attributes. I mean, you can. If you really want to, you can. So it says, I came up with that. I also used latex. You made this in LaTeX? Oh my god. That's incredible. I can't believe you actually laid out an image and it's centered. Underneath two images that aren't set. Like, you did good. King Buns, what the fuck is wrong with you? King Buns gives us a bog champ because we got no mangle working. Where was the other place that we had attributes done? By the way, the thing we should probably do. We're just going to have a void parse function attributes. Tribs. Then we're going to say fill tribs parameter with parsed function attributes. Well, that's kind of going to be a mess because how do we deal with this? Yeah, we're going to leave it for now. We're not going to go that far. It's fine. We have functions covered, lambdas and other. King Bun says, I mean, LaTeX, or sorry, I mean, LaTeX was my first programming language, so. King Buns, but at what point do you just accept Google Slides? Ugh. What is that? Sorry, it says Google Slides. What's that? Hearsay? Yes, it is hearsay. Okay. Wasn't there another attribute spot? I could swear. Collect attributes for this type. That's right. So I kind of need to find wherever we parse attributes and do this type of thing. Where did I feel like I was very near the bottom, but apparently I was not. There we go. Okay. Okay. Collect attributes for this type. Attributes of tribs equals 0. Type attributes. Let's do struct type attributes. Align as. We have attribute kind. The word hearsay exists. Lenser, hearsay. How do you say it? King Buns, Lens, do you have a favorite drink besides water? You strike me as a root beer person for some reason. Oh no. What have I done? A root beer person? No, it's pronounced heresy. 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 It's pronounced heresy? That doesn't sound right. Heresy? What does that even mean? Is it like blasphemy? No, I do not, Molly. Soraid says, there we go, yeah. That's how it's pronounced. That's one way. I like saying hearsay. Heresy. Yeah, exactly, heresy. That's really good. Hair AC. So it's definitely an error if we don't get a brace. By the way. So unexpected identifier when parsing type attributes? Sure. So it's yeah. Oh, Molly, do you use LLVM for anything in this project? No. It will never be the main focus of this project or the goal. If we happen to support LLVM, that's fine. Our IR was inspired by LLVM IR to some extent. I'd say to a very short extent. There was a lot of me going, I don't think we should do it like that. And you're like, but that's how LLVM does it. And I'm like, we're not going to do it that way. Whether that was a good decision or not has yet to play out. So we get an attribute kind. So we're going to switch on attribute kind. Right? Yeah. Why are you mad at this? Oh, probably just because I'm not handling. Molly the man, but you already have code gen. Why do you need LLVM? We don't have code gen for everything. We have a very limited code gen, which is also using our own register allocator. And there are bugs in it. There are bugs in it, right? So LLVM is used by so many people that bugs in it that are trivial are going to be found and fixed. Whereas ours is basically unused compared to LLVM, right? It goes unused. Whereas they get used by, I'd say, millions of people every day. So they've kind of got an advantage there. So we don't need LLVM, but we will probably eventually support it just because, one, it will kind of allow us to, so it says, yeah, everyone uses LLVM. Exactly. It will kind of allow us to mesh in with other languages that use LLVM. So like if you want to create LLVM IR and then use that to link with Rust, it's probably a lot easier than creating like x86, 64 object files and then linking that with Rust, right? So you can probably get better like internals with other languages just because LLVM IR is so shared. Clang uses it as well as Rust and a bunch of other languages. Exactly. I just don't like it because it does too much for me. I like to do all the things that it does. So it's kind of an issue. I don't think you know how Python works. Invalid attribute for type. Invalid type attribute. New attribute dot kind. Why not? And then this, we're going to have to parse a number, which I don't remember how to do this. So we've yeeted the identifier. So we're going to say if p token type does not equal token number, error, because the align as attribute, type attribute requires an integer number. If ptoke type does not equal number or ptoke, so if the token, I feel like there's a way to tell this, but I can't remember. So if it's a number, doesn't it become like a literal? It's just stored an integer, isn't it? Because we don't have floats. Okay, so that is an integer. The align as type attribute requires an integer number. Have I started a code war in the chat? I have. Lots of things happening in chat right now. I'm gonna skim over before I get locked on one side or the other. Ptoke type equals number. We require an integer number, in which case we can now say new attribute value integer is equal to ptoken.integer. And then I can probably put a static assert here somewhere. Exhaustive handling of type attributes. Here, I'll just put it, yeah, I'll put it by the switch. Exhaustive handling of type attributes. Good enough. We don't have floats. I just spent 2 hours making a meme to tell us all to stop using floats, and you forgot we don't have them. Yeah. Yes, Your Honor. I feel like I need the mic feedback sound on like a hotkey so that I can make it sound like super awkward. Like, why do courtrooms always have the worst mics? Anyway, we got a new attribute. Align as, hopefully. We're pushing this into a vector of attributes, but it's never being used. So I think we're just gonna do this. I mean, we kind of have this here too. I don't know if we need to, but we're gonna have them. So remember the function attributes? Oh yeah, we have to apply them. So the application of function attributes is something we should make a thing. Watch. So we're gonna have just like that. Apply function attributes. Which takes in a function, and it takes in attributes. And a parser. Oh man, sorry about that. Okay, this will be interesting. There's gonna be more dings, just so you know. Warning given. So we need the parser because we actually need that for errors. Unless we use arrat. Well, it still needs the parser, even if we use arrat, but it does let us give a location, which would probably make more sense. Attribute cannot be applied to function. in the attribute, we don't actually know where it is. We may want to add a source location to each attribute. That may not be a bad idea. We can just do the func source location. We still need the parser P just to check. We do. Okay. So apply function attributes P. And then, where else do we parse function body? After we get the func, we apply function attributes. Yeah? Why are you mad? Because that's defined after. Okay, lol. Definitely going to be an issue. Let's put it like near the top then. Yeah? Apply function attributes. Helper to apply each attribute within attribs to function. Errors if a non-function attribute is present in the given attribute list. Calls error. Serade at Lenser. Python backend when? King Buns, they made some decent improvements with 3.1.1, but it can only get so quick since it's a dynamic garbage collected language. Exactly. Until Interceptathon becomes popular. Python backend when? King Bun says, it's a good name, I'm proud of it. Molly the Man says, yes, add this to the roadmap. Honestly, it'd be really easy. If you don't have to deal with any limitations of like static typing or register sizes or anything like that in the back end, right? So if you just don't have to deal with any of that, everything can just be like when we look at the IR, we can just make a variable for each one that compiles to Python. April Fool's stream next year. Idea. Oh God, Serade, no. You're scaring me. Just compile to Python, link in a Python interpreter. Yes. And use that for compile time evaluation. Can you make something like Jai the ASM when you write assembly in your language, or it's so hard? No. If you want to do anything like that, use the linker. Does the JVM static typing have a significant performance improvement over Python? Yes, it's static typed. And yes, for a million reasons. I love how everyone in the chat has read it and went, yes. There was no other answer. Actually print out attribute string or something like that. Sure. So I'm actually going to move all this to above and say attributes. But I want like this thing. Okay. And then I think this thing should go up there. Yeah. Struct type attributes. Perfect. Okay. I do have to... I'm going to turn the fireplace on or something. Struct type attributes. Hopefully this works. Okay. Ace Attack, thank you so much for the follow. I appreciate it. I am going to be in the room. You'll hear me, but I have to do something for someone that they've asked me to do. So you guys are going to watch the fireplace, talk amongst yourselves. You'll hear me in the background cursing at myself as I try not to fall. But yeah, I'll be right here. If you have any questions, now's a good time to ask, and I'll answer them when I get back in like a minute. Oh, God. Jesus. For one. Okay. For two. Oh, Jesus. Okay. Okay. I did it. Oof. Okay, I can put out the fire. Thank God. Okay, what do we get in chat? What do we have? Molly the Man asked about, that's right, assembly, Suraid. Oh, everything moved. Hold on. Suraid says inline assembly is easy. Inline assembly with proper clobbering and all that, not so much. Exactly. Hopefully that answers your question, Molly the Man. We can do inline assembly. Like, it wouldn't be technically difficult. It's just that we don't do... That's not really a plan. Why would you need inline assembly in Intercept? I don't see the use case for it. That can't be covered by another use case. Because, like, we have CFFI, right? We're following the calling convention. So from Intercept, all you really have to do is define an external function and then define that external function in assembly, follow, you know what I mean, some calling convention that you're going to compile with, and then bada bing, bada boom, Intercept and assembly can work together using the linker. So inline assembly is possible. It just doesn't seem like something that's needed or would solve any issues or anything like that. Just write a library in assembly, right? Moldy the Man says, no, it's just cool. I guess. But anything you can do in assembly, you can do in Intercept. At least simple assembly. We're not going to have like vectorization for a long time. Because again, the register allocation stuff. Moldy the Man says, it's so cool. What is no mangle or align as? And then, oh, okay, again, what is no mangle? What is no mangle? What is no mangle? I'm sorry. I'm sorry. I'm sure you've asked it a million times and I just skipped it on accident. No mangle is an attribute. An attribute is like some piece of code that changes how some other piece of code works. So if we take a look at this simple example, we can look at why. Right? So we have foo. Here, let's start with nothing. We have foo. This is just an identifier, right? Now we want to declare a function which returns an integer. So now you can see foo has a type of integer function, integer returning function with no parameters, right? And then we can just make a body. We could either do equals or not, doesn't matter. We can make a body and let's say it returns 69, right? Cool. And then we can call foo. So let's just try this and compile it and see what happens. Cool. If we take a look at the IR, we can see that it's not complicated. That is a little, oh, it's terminal bug, haha. Okay, there, terminal bug fixed. Moldy the Man says, cool. So if you look at the IR, that's so crazy it skips that line. I don't know why. It is there. It's just not showing for some reason because of this stupid Windows terminal. As you can see, main, we just call foo. And foo, it just returns 69 after it loads it, right? Just returns 69, just calls foo. It's very simple. However, to compile this, foo is not foo. That doesn't look like foo to me. Does it to you? It's in there. Foo is in there, right? But this does not just look like the name foo. Molly the Man says, what is this, Lamau? Right? So underscore X is equal to just a prefix. So this lets us know it's a mangled name. Right? F equals function. Begin. Ends at E. Right? Which also tells us what E is. E equals function end. And then you can see 3 foo. 3 is equal to the length of function name. We have F, which again, this refers to the function types, function return type begin within an F. As far as I know, I may be wrong about this. You'll have to ask Saraid because he helped with this majorly because it's confusing. And then you can see 7 is equal to the length of function return type. And then you can see that integer, we skipped foo here as well, I guess. Name of function. And then we have integer, which is the actual return type of function. Then we have E, which is the function end. Is it custom mangling or something compatible with, say, Microsoft or GCC? Custom. Molly the Man says, why do you need all this? Does the compiler needs all of this, or is it just for random names? We definitely wouldn't just do this if we didn't need to. This is a whole bunch of work. There's 2 main reasons why. Quamar says one of them, which is function overloads, which we'll get to, but the main reason is actually for modules. Module A defines foo, right, as like n, which takes in an integer and returns void. Right? Then you can imagine that module A actually only contains the name of this. This type information is thrown out. So all it contains is foo, right? And it binds it to an address. Some address defined by the linker, right? Foo is just some address defined by the linker when we define it like this. So when module B uses foo, module A, right? How does it know what foo is? What the signature is? How does it know what it is at all? Right? How would it know what foo is at all? It wouldn't. So with this mangled name, the type information, mangling encodes the type information into the name of the function. Molly the Man, wait, do you have modules in your language? We will. It's on its way. It's very soon. Source has modules in it, which Saraid's language. It's looking very good. Normally, you'd probably have some additional metadata besides relying just on the mangled name for type information. But sure, that's one way of doing it. Exactly. That's not necessarily the implementation, but that is one reason why you need mangling. Another reason, as people have mentioned, is for overloading. So we have overloading on functions where you can define two functions of the same name and the same return type as long as they have different parameters. So this function, which takes in an integer, will return 42, and this function, which takes in nothing, will return 69. So now the issue is that if we just had foo, like here, how does the underlying code actually know which foo to call? And actually, it doesn't even allow multiple foos to happen, because if you had two things named foo, two labels named the same thing, you'll get a problem from the actual assembler when you try and assemble it, like using GCC or something. This won't work. And it says error, symbol foo is already defined. So you can't just pass them through. Also, this is going to go horribly. Hold on. I clicked the wrong button and now stuff is popping up. So we can't actually have both be foo because that is an error in the output code. So we have to mangle them when we have two functions of the same name. And that's allowed in intercept, for example, here. So when we do this, you can see everything's fine. We have foo. They're two different functions. Everything's fine. Intercept doesn't yell at us. And it actually creates the proper code because these are not called foo. One takes an integer parameter and one does not. Overloading is why it's necessary. It's one of the reasons why it's necessary. Module? Okay. The signature of foo, exactly. The compiler needs it, not the user. Why do you have it as a keyword in the language? Wait. Am I missing something? I'm probably missing something. I'm not sure what's becoming a keyword, Molly the Man. Do you mangle void as void in the signature? I think it's just for void, yeah. But yeah, so that's why. Another thing that we'd probably want to do, now that we have no mangling, right, there's going to be a bit of an issue. We still allow overloading a function that has a no mangle attribute, which should not be really allowed. It does work, I guess, which is kind of scary. Oh, honestly, this might be really awesome. Saraid, what if we just didn't allow two of them to have no mangle? What if we allowed one of them to have no mangle in an overload set? Is that kind of cursed? Saraid says, funny that you should mention this. Because it should be able to... I suggested disallowing it. You suggested allowing overloading. I love the you. When we last talked about this, I mean, yeah. I think I remember that. So, I guess the thought of it is that this foo can be called from C, right? And in fact, this foo can even be an external function that has no body. I'm convinced Saraid talks in Markdown IRL. Lamau. But we could have a no-mangled foo defined with no body And then we could have foo with overloads that calls foo, right? And then does some spectacular stuff, right? It can do whatever. Serrate asterisk, perhaps asterisk. But this would mean that we can call foo, which is like some C function, and then we can call foo, which is like some C function, but then also pass things into it and do more stuff. And if you can imagine, right, let's imagine puts, which has a byte pointer, right? Just looks like that. What if we end up with a string type, right? If we end up with some string type, we can't just pass this to puts, but we could eventually define puts as another thing, right? This might need no mangle depending on how we handle ext right now. I don't really know. But we could actually define one that takes in this string that says like string is actually a string, and it calls puts with string.data or something like this. That way we could have an actual C function overloaded. So we could overload C functions and intercept, is like the idea. Moldy the Man says, Lenser, no mangle is a keyword. It's a conditional keyword, but yes, it is. So it's a contextual keyword, I think. It definitely is. It's not an actual keyword. You can name something no mangle. That is fine. So it says, I'm not sure, I was making a meme. Yeah, if you want to check it out, here you can see they are not part of the keywords. They're their own structs. They're much like keywords, I will admit. Sraid says, call a function no mangle and make it no mangle. Oh god. But yeah, so I'm thinking about allowing for stuff like this because it seems intuitive. It seems like the thing you would want to do. And then to provide a C API, right, called from C, then you could say, oh, this is an integer returning thing, and this one is no mangle, which means that when you call this from C, this is the one that will be called from C. But then you could also have your own non-no mangled overloads of it. It seems kind of crazy, but it also doesn't, right? I don't know. No mangle is a function, no mangled, which returns 69. And then we're going to call no mangle. Just see what happens. Did I leave that in? I left that in. It's like shadowing in Rust. It's not, but yes. It worked. We have a function called no mangle, which is no mangled. And I'm pretty sure we can undefined reference to foo. Ah, yeah. It's literally an undefined reference. It's been a while. Still an undefined reference to foo. That's an interesting one. I'm kind of curious why that is. So we have global foo and crazy foo. We call foo. We call exponential foo. But we don't actually have foo as a thing. So foo never gets defined in the output? Am I crazy? Isn't that what this is? I keep forgetting that this language doesn't have return at the moment. Definitely. Makes it kind of confusing. It worked. Okay, Pog. Pog. Champ. Ext functions aren't emitted. Did I have it as ext? Hold on. Ah, I did. I did. Okay, that makes a lot of sense then. Poggers. Yeah, so as you can see, we could allow something like this, which allows us to have a foo function, but also an overloaded foo function, which returns something else or does something, some spectacular stuff. I'm pretty sure ext functions don't have a body either. You're probably right, so we ended up with just a function and then a block. So with ext, that literally was just a declaration followed by a block expression that contains 69. Yeah. We're gonna get rid of ext eventually. So ext makes it no mangle. That's at least something that should happen. Right? So create a symbol table entry, redefinition, create the function. Yeah, we don't ever parse a function body. External functions should not be mangled, I don't think. Then I guess it's just a symbol. We need func. So func, we have function, attribute. What do we got? No mangle equals true. External functions should not be mangled. Is that correct? What do you guys think? I think external functions don't make sense to mangle because they're defined externally somewhere else, aka not in this language, aka they're not mangled by this language. Electri, can you override with a different return type? No, not at the moment, but I'm not averse to allowing it. I've been thinking that's something I'm kind of wishy-washy on or ambiguous. Currently, no, it's not allowed. We have very much C++ style function overrides, I would say. Mm-hmm. Yeah, especially because we're probably going to make it so functions are not exported by default. Cool. So let's run our tests. Well, that's a good sign. So if you want to use the function, you can literally just import the module. That's exactly what we're planning on. Yep. And you can't access non-exported symbols at all. That sounds correct because the linker doesn't export them. Yes, yes, yes. So external should just be like, give me this name as this type I'm declaring it as, and don't ask any questions. Coolness. So we have all of our tests still passing. That's very good, or at least the ones that were passing. I think that's good. Attribute no mangle. So we did attributes. That's kind of crazy. I didn't expect it to be that easy, but we did do attributes. And then we were in the middle of applying something, weren't we? It's not in a to-do anymore. Yeah, struct type attributes. Here. We did end up applying these, okay. I think I'm going to move this as well. This isn't even applying. Yeah, see, we're not applying them. Ah-ha-ha. So now we need to take this out. That's a struct type. And then we return parse type derived. So while we're parsing this type, this struct definition, before we consume left brace, then we parse things. So we get the identifier if it's an attribute. Where does that actually go to? Is that here? That is here. Okay, so this is our while loop, right? Is this our while loop? Where does our while loop end? So we loop over, we find our attribute, we skip it, we do data parsing, etc. Okay, so now we do just need to apply it. But what are we applying to? When we get a token type, we're actually just defining a new type. So yeah, this is basically going to be a switch. We're going to be looping over. Yeah. It's literally just this. And instead of a function, this is now a type. And out, this is going to be a struct type. And we are setting its alignment to the attributes alignment. Attribute cannot be applied to type. Apply struct type attributes. And it's going to be a static void, which takes in a type pointer type. And some attributes. Why are you mad? Same thing as before, we need the parser. This happens after Sema, I'd hope. It does not, because Sema will override that for sure. Why? Why would it do that? I think it's fine. It won't work, I guess. Because normally it starts at 0. Ananta, thank you so much for the follow. Good looking, you have the voice of an angel. Can you sing me a song? What song? I don't think my voice is that great. Sraid says, I guess it just picks the maximum. Ugh, not the compiler dev opera. But the fact that it works is an implementation detail at the moment. Well, what would you suggest? Like, what else would we do? We would just have to say, like, bool has alignment equals T structure alignment. Is that better for you? I would prefer something sad, something that will make me cry. If you have an example, I'll go for it. So it says, add a comment here that says, may have already been set to a higher value by align as or something. I see. Is there anything wrong with this? Let's go with Justin Bieber, baby. I don't remember that. I remember that's like a meme and I should know it, but all I'm remembering right now is call me maybe. So it says, I mean, sure, I suppose that works. Well, that's good. But then you also have to do it below. Where? On line 719. Why? That way align as always overrides the natural alignment. That's how it is right now. This just changes the byte size, has nothing to, it doesn't change alignment, just reacts to it. I think that's fine. I'm not doing anything crazy here. We could even, so it says, oh yeah, I missed that. Silly goose. So we still align each element on its own alignment, but the entire struct is forced to an alignment if it already has one. If a struct already has its alignment set, then we will keep the alignment of the struct to what it was set to, assuming that whoever did it knows what they are doing. In my defense, this is why I can't stand line wrapping, because I can never quite tell what's going on. I mean, that's on you, brother. Line wrapping isn't difficult to understand. I'm sorry to say, but it's quite natural. I agree it's not like easy, but there's no alternative. The alternative is have stuff go off the screen, and that doesn't make it easier to see either. It just means that you now have to scroll from right to left all the time. Line wrapping is pain. It's not that bad. This is going to be the dumbest question you may have ever heard, but how do I enable line wrapping in Emacs? Control X, XT. Here, we can even we can even show you. Here's me pressing it. Poggers? That's it. Control X, XT. If a struct already has its alignment set, then we'll keep the alignment of the struct to what it was set to, so that whoever did it knows what they are doing. Sure. Could this cause an issue? It could cause an issue. Because if we align something, then the byte size will be plus the alignment. But then, yeah, this is fine. Everything's fine. we may get a misaligned member, but that's not our fault because it has an explicit align as. Is line wrapping on by default? Yep. I'm sure I've said it that way somewhere in my .emacs, but it is on by default for me. King Bun says thank you for your service. Of course. But yeah, so this should be fine. Our tests are still passing, so that's good. I think we're going to call that good. Could we add a test for what we just added? Let's do... We can't really add a test for what we just added. It's really not different to have to do this and have the screen jump around all the time, or do this and have to go, what line am I actually on? I agree, it's fair to prefer one over the other, because obviously I do, right? I just think one isn't objectively better or worse. Can also just add a line break. Where? Nowhere adding a line break does this make more sense. Ah, yes, the classic. Whatever this is. This isn't easier to read. Anything is better than line wrapping. Much better. I mean, that's your opinion. That's just like your opinion, man. You know? That's right. I did do that. I don't think I ever used these. I never used the attribute makes. I can probably get rid of them. Right? Yeah, I never used them because it doesn't really make sense. We either already have an attribute, and why would we, like, use a function? Yeah, I don't think it makes that much sense to have the makes. We're just not going to need them. You can just make an attribute. It's not hard to understand how it works. We can add those back if we really want. But I think this is fine. Okay. Attributes. Attributes. Here we're setting no mangle for the IR. Here is the no mangle attribute for IR functions. Instead of doing a string equals and is extern, we now just check no mangle. The parser gains a bunch of attribute parsing and application. That gave me an aneurysm. Was that bad, huh? King Buns, one more noob question. Why do some package commands have a plus prefix in front of them? Does it denote something? Ah, yes. I can't remember where it is. Yeah, this isn't it. There's somewhere in the info manual, King Buns. I can't remember where it is for the life of me right now. Where it goes over like naming of variables and stuff like that. I can't remember if it's in Emacs or in the Emacs Lisp intro. But it's something like that. Yeah, I can't remember. It's somewhere though. It is somewhere, I promise. But there is some sort of naming convention that they go over a style guide, and I believe they mention plus in it. So if we check out GNU Lisp, Emacs Lisp style guide or something. Reference manual. Naming. Coding conventions, that might be what it is. This might be what it is. This is what I'm remembering for sure. Yeah, so separate the prefix from the rest of the name with a hyphen, blah, 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 intended for users. This is an insane amount. In Common Lisp, global variables conventionally start and end with star. That's called earmuffs in Emacs. You do have to put earmuffs on things. We can check it out. Here it is. Those special names are used for buffers that are not associated directly to a file. So you can tell that when I go to Scratch, Scratch has earmuffs because this isn't actually a file called Scratch. It's just a buffer that isn't associated with any file called Scratch. Those are the earmuffs. I don't remember the plus. I don't know if it's here, but it would be here if it meant anything specific. They're saying don't use earmuffs in your programs, please. But yeah, there's actually nothing as far as pluses in their coding conventions. There's also major mode, which I guess it could be in here. Yeah, so there's all of these. No plus on this page. No plus on this page. I don't think hooks start with plus. I've dealt with a lot of hooks. Is it an advice? I don't think they would recommend you to name an advice differently. Yeah, no. I don't think there's anything officially in the Emacs manual about it as far as the specific plus prefix. Yeah, and there's nothing here. Should be good. I don't know. It's probably just made up by the whatever package does it. What was the command to set the command suggestion algorithm? What? The command to set the command suggestion algorithm. Oh, this thing. Down here, like mini buffer stuff. It was like autocomplete for MX. Yeah, so it depends on what auto-completion framework you use. If you're using company, what is it? It's company backends. And as you can see for me, this is dun, 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 company capf. And then local in this buffer, it's this. Which basically means that we, okay, thanks, I have company as well. Nice, but yeah, you can use this and set this value and read all about it. It's really complicated to actually I think there's another way to do it. Yeah. So company begin backend can be used to start a specific backend, if that makes sense. So company begin backend, if you call that, then you should be able to enter a backend that actually is one of these, right? And then it'll just make that one active. But if you want to actually set it forever, then you can do this stuff. And there's all sorts of stuff you can do to try and make it more efficient if you need that, but it's good. Do we have everything we need? We did the struct alignment fix for align as, and I think that's us done. We can't really add a test for no mangle because we kind of just can't, because how would you tell if something is mangled in the output code or not? It'd kind of be an abnormal test and not just one we can run like normal. Function may retain its exact name even in the code generated by the compiler. It's maybe for use in programming in another language. Like C, ext is like attribute, no discard, export. Except then as a special condition, so any variable may have those properties. I don't think that's important to go in this example. Ext is like, why would no discard? I think I meant no mangle. Yeah, I don't need to specify that stuff, I don't think. We don't even need puts or anything like that. We can just define no mangle as a thing. Perfect. Just for fun, to show how no mangle is only a contextual keyword, we also call the function no mangle. Cool. I think that's a better example. That's the staged. I want the unstaged. There we go. And I don't think I need any of that. PogChamp, PogChamp, PogChamp. We did it. So now we can say da-da-da-da, attributes. We've gained function attributes. Well, one of them, no mangle, as well as struct type attributes, line as, which we should probably check actually first. Okay, so we're not going to commit that yet. We're going to save that. And then we're going to try and make an attribute align as example or whatever. Again, no test really for this, but we can do foo, which is a type, line as 16, which is just an integer. King Buns, do I go watch the stream at a Mexican bar and get Mexican food or order pizza? Tough choice. Well, I'll let you know. I've got to go soon, so don't base it on what I'm doing. You have a fun time for you first, if that makes sense. Because I don't have a ton of time today. Left, I should say. Don't have a ton of time left. I've already gone for a few hours. Honestly, if I were you, I would just order pizza because I like staying at home, but I like Mexican food a lot. So if you have some, like, I'm in the middle of nowhere, Montana, there is nothing. It might be a good idea to go to a Mexican bar and get some Mexican food then. Because, you know, sometimes you just have to do something. When you're in a small town in Montana, I'm going to dox you. You're in Missoula. No, are you in Butte? That'd be like a really small town, right? It was like 1,000 people, 5,000 people. I don't know. All I know is eastern Montana. I don't really know western Montana. Over by the North Dakota, it gets weird. King Buns, dude, I'm homeless. You can't dox me. Lamau. I'm in Hamilton, which is 45 minutes south of Missoula. Oof. F. Do you like it there? How is it? I've been to Montana a few times. I have something there. Expected blah, but got number. Good thing we tested it. Oh, I know what we're doing. When we're parsing an align as, you know what we're not doing is next token. Eat the number. Poggers! Okay, it worked. And do we actually have... We didn't create any one of the struct types, so it'd be great if we could do A is a foo. A.n is equal to 69 A.n. That's better. And when we see this in the AST, we should see it is a size 16, alignment 16 with one integer member. Pog, it worked. It affected the size of the struct as well. Is that allowed? I feel like that's a bit messy. First time chat from CalcMath. Hello, may I ask what you are working on? A compiler that turns source code of a custom language that I've made up into an AST, does semantic analysis, and then generates it into IR, and then the IR gets generated into assembly. CalcMath says that's a cool AST printout. Thank you. Sraid says that's not only allowed, otherwise you can't have arrays of these things. Oh, interesting. Yeah. Because they'd overlap. So even when you do that in GCC, like if you put align as 16 on a struct in GCC, it becomes size 16. I just want to make sure it's not like doing something hidden that isn't expected. Smoking Ears, thank you so much for the follow, and I like your name. Oh, chat. Oh. Do you know what time it is? It's 4:20. Oh, I moved the wrong window. It's 4:20. Oh, Pog. Do you use LLVM? Never. No, we don't right now. We can, though. It's a back-end agnostic is the idea. We had... Oh, King Buns. I mean, it's not bad. The weather in the Bitterroot Valley is only gray right now. I am so moody without sun. It's crazy. It's way smaller than Butte, though. Not much here. Smaller than Butte kind of hurts my head. I'm sorry. I've been to Butte. You can literally see both ends of the town. Like, if you stand at the Butte Mall, the biggest building in the town, you can see both ends of the mall, and that is equivalent to both ends of the town. I almost swear to you. There's a highway on one side, and then on the other, it's like a quarry that's like, it feels like it's a mile away. Like, you can literally see the entire town, which is crazy. It's just, it's so small. It's not a bad thing, and that's why I asked if you like it. Without the sun, yeah, it's just been overcast here as well. It's really bad. I just want it to be sunny so that things dry up, like on the ground, and things with wheels don't rust. King Bun says, yeah, and only 2 days away from 420. Oh, that's true. I'm so excited. They're going to have some good sales. Yeah, I think I handled everything. Ended up at this weird bass EDM show in Missoula last weekend. Awesome. I almost read that as bass, like fish, because it's Missoula. King Buns. Yeah, the toxic quarry that kills birds that land in it, and the statue of Mary looking over the town, and the locals say she is the only virgin in Butte. Yeah. I know somebody who swims not swims, it's not allowed anymore. They swam in the quarry, in the water in the quarry, until they were forced not to. I don't know how they're still alive, because there's some bad stuff. Like, even if you, it's so clearly bad. What is your language called? Intercept, and is it on GitHub? Yep. You can check out the About section on Twitch to find a bunch of links, or do anything, really. Check out my YouTube, by the way, as well, if you're interested in previous stuff. But yeah, it's on GitHub. It's got its own repo, contributors, and stuff. I really recommend checking it out. It's got a nice README. I try and do good on that to make it easy to build and understandable how to use it. King Bun says, yeah, their child is going to have 12 toes. Most likely. Here's a compiler explorer link. Oh, beautiful. Thank you. What am I looking at? So we have struct foo, which is a type, I8. Oh, that's cursed. So there's syntax for multiplying how many I8s. Then there's 4,095 invisible I8s. Okay. They use I8 no matter what. Had to know. I was like, wait, does that matter? Does it fill it with the rest of the member type? I was like, that'd be crazy. Also, we've got some Godbolt going wrong stuff. That's a little scary. Program return 255. Yes. Don't worry about that, says Sarade. I'm worried about that. So yeah, they do increase the size of the struct. That is very nice, by the way. Thank you. Just because of align 4096. Not 0. Thank you. That actually helps a lot. It puts my mind at ease that we're not screwing up. I don't see a use for that increasing the size of the struct. Here, I'll do it for you. Sorry I said it earlier, but I'll do it for you. How would this work? So if every foo needs to be on a 16-byte aligned address, then an array of foo, each element is separated by alignment bytes. If it's greater, here, by at least alignment bytes. Right? So if alignment happens to be greater than size, size needs to increment just as much to match alignment, otherwise you can't have an array of these things. Eletri says, yeah, that makes sense. Legendary. I'm glad I could help. I am glad I could help. Cool, cool, cool. Interesting. Requested alignment is not a power of 2. I didn't know that was a rule. That's an interesting one. Should this be a rule in intercept? That should almost definitely be a rule in intercept. How do we tell if it's a power of 2? Convert it to a float. And check the mantissa. That's a little complicated, but we could do that. We could also divide by 2 until we get 0. And if modulo 2 is ever not we could check the bottom bit. If it's odd, it's not a power of 2, right? If only one bit is 1, it's a power of 2, so do a pop count. Gotcha. That makes sense. I think we're going to have to implement our own pop count. And then on GCC, use the built-in. GCC or Clang. Calc math. I am currently working on a Lisp interpreter in C, after which I want to write a C compiler in my Lisp. Is that a good project idea? That's an amazing project idea. That's really cool. And MSVC has pop count, GCC has built-in pop count. I mean, that's kind of annoying to have like compiler dependencies just for this, because a lot of this doesn't rely on a compiler. It works on all of them, right? I think vector is like the stuff that gets into this not being the case, but I think these do all work on MSVC and such. Yeah. So it says they do work on MSVC, sadly, yes. Okay. Is there like, can we just implement pop count and then have it be an optimization? So let's just have like, return the number of bits set in I. Right? And we can do if def GCC or whatever. I don't actually know what this would be. Something like that. If def GCC, then we can actually use the built-in. Otherwise, we're going to have to do this our way. And what we're going to do in here that doesn't help me. GNU-C. Okay, that's what it is. Interestingly, I think we could do this. And it might be a little more sensical. So we can define pop count like this, or we can define it like this. What do we need to include? Where is built-in pop count? It's a built-in, so we don't need to include anything, I guess. Cool. if defined clang pop count. Perfect. GCC and clang. So apparently GCC has it built in pop count on an unsigned int, by the way. Yeah. Something like that. And then we can say clang has hopefully the same thing. Clang built-ins? Is this what am I looking at the right place? Has built-in. Just do n and equals n minus 1 in a loop. GCC recognizes this and optimizes it to pop count. What? N equals n minus 1 and equals n minus 1 in a loop? How does that tell us how many are counted? I'm confused. They also have built-in pop count. So it's something like that. I can't remember. Underscore MSC underscore ver. I was near. And then MSVC pop count. Oh, sorry, it said that. I remember. MSVC has underscore underscore pop count, apparently. Cool. Are you using your own custom editor Lite? Not yet. No. I'm working on it, but it's not stable enough. It crashes a lot and I lose progress, or it just freezes and I don't know why. So I'm working on it, but I don't use my own like on stream. I do use it to edit files. I am getting better at it because I have it actually in my path now. And you can see that I haven't installed the actual shaders to the proper spot because I was working with the SDL2 version. This is Emacs then. Yep. So it says, look at the Godbolt link. Well, n count plus plus n equals n minus 1. Well, yes. I don't know. I think this is fine. Are you saying I could change this? So say while I plus plus I and equals I minus 1. Oh, but then count plus plus. That's what you're doing. Interesting. is this reasonable? I think this is reasonable. Cool. Return the number of bits set in unsigned integer I. I screwed up the chat. This is a common pattern, so much so that it's hard-coded into optimizers. That way you don't need all the if-defs. Yeah, that's true. We can just use this as an implementation. What are we doing this for? Align as, I guess? If pop count of integer does not equal 1, the align as type attribute requires a power of 2, which, is not. Beautiful stuff. I'm pretty sure you can also just do n and n minus 1 equals 0 to check if it's a power of 2. See also the message I sent earlier, the long one. Did I miss one? Oh, I did. N and n minus 1 sets the rightmost bit of a number to 0. If you look at the Godbolt link above, you'll see that GCC recognized and optimized to use the pop count assembly instruction. Maybe an earlier message. I don't see one. Maybe I'm crazy. So to check if it's a power of 2, you're saying we can simplify it? No, I meant that one. Okay. But can't it then go on to not be 0 and be false? I think you're checking if something is even there, right? Not whether something is power of 2. Maybe I'm wrong. Result of n and n minus 1. If you'd like, and minus 1 is going to be, it's a difficult one. So there's no 1 here, there's no 1 here, there's a 1 here. So that's going to become 10 here. Interesting. So what you're saying is if we have something like this, which is a power of 2, if we minus 1 from it, we're going to get this. And then if we AND those, obviously we'll end up with 0. Right? I get what you're saying here. So if we have something that isn't a power of 2, and then we AND it with minus 1, what is this minus 1? 1000 minus 1 is 999, but that doesn't work. So it's going to be 111. And then when we AND, right, so when we AND it with that, we're now going to get the power of 2. Interesting. Yep. I can't like think of little rules like that. I have to just know like the underlying math and treat it like decimal and then convert to binary. Because like I know how to do 4 plus 3, you know what I mean? I can go, oh, that equals 7. And I know how to do 4 plus 7, and I can go, oh, that's actually 11, so you get an extra 1 here, and then that's actually 11. So I just do this method, but with binary. But yeah, so that makes sense. So what we can do, what you're saying, is not have pop count at all. We don't actually need it. We can have power of 2. We can go back to use size, because we don't have to use the built-in, and we can say return I and I minus 1 equals 0. It's like if you subtract 1 from 10,000, you get 9999. Exactly. If you subtract 1 from 10,000 in binary, you get 1111, which is 1 less digit, and each digit is set to the maximum of the base. So this little function tells us if it is a power of 2. I'm not going to explain why. And then we can just do this and say, if not is power of 2, the align as type attribute requires a power of 2, which is not. Beautiful. Beautiful stuff. Okay. What's the actual exact error that we got when I changed that? Oh, I've since changed it. Okay, I can go here. I have it open. Requested alignment is not a power of 2. I think this is more better than that. We don't need any built-ins now. That's good. Rely less on built-ins. Stop using floats. Oh, that's so good. So good. Okay. CalcMath says, nice trick. I like the power of 2 function. Legendary. I'm glad you like. I love how that just keeps popping up. It is pretty great. Attributes. We've gained function attributes. Well, one of them, nomangle, as well as struct type attributes. Align as. Cool. It's linked in the Discord. It was posted in the off topic, but it's this thing. Oh yeah, pin it. It's pinned in the off topic now. Hey, I gotta check that out. Mark is unread. Beautiful. We have attributes now. Did I forget anything? I guess I could have done attribute align as. That might have been important, but it doesn't matter. I think people will figure out how it works. Sorry, it says, I made it. It's on Discord in hashtag off topic. And if you're not sure where to find the Discord, check out the About section down below while I'm live on Twitch. And if you're on YouTube watching this, it's in the description. Check out that invite link. CBDCBN, I don't know how to say this. CBDCBNTH17, thank you so much for the follow. Portugal9, thank you so much for the follow. And Gent TV, thank you so much for the follow. Is that gent enough? Calcmath says, thank you, found it. Legendary. Legendary gamer moment. Ooh, we can fix up CFFI in a way that doesn't suck anymore. So CFFI is a way that we're calling C from intercept and calling intercept from C. And you can see that before we had to do this nonsense because of not having no mangle. We can now, we can't call it sum2 because we already have sum2. So we're going to have to call it something different. So this is going to be sum2 impl, right? So when we call sum2, we're calling out to C. C is calling return sum2 impl, and then sum2 impl is just actually doing the adding. So it says you don't have to do anything because you don't need the wrapper in C anymore. You can just use the extern function. Where? What is this? CFFI. That's right, that's right. Perfect. Oh! Pog. Pog champ. Or are we calling into C? We're calling into C. This is our intercept and this is our C. But yeah, with no mangle, this is now, I think, worthy of being an example. So that you can define sum2 impl. This is an intercept function. That will be called from C. This is a C function that will be called from intercept. And then obviously numbers has to be defined for both of them. We need type information. So it says I see, it's going both ways. Yep. And this allows that to happen kind of rather nicely. Let's just make sure that still works. I didn't break anything. There's the CFFI. There's the compilation. And it returned 69, sure enough. This is just for subtraction. It's really not important. We could emit different instruction mnemonics based on operand size, but currently we're using the default in almost every case, so it doesn't matter. But it is something we should fix up, not have that anymore. Calcmath says, in your meme right panel, I recognize that as the fast inverse square root, but what is the left panel? Guessing you meant to at me. It's just some random x87 floating point instructions. Yeah. My favorite is oops, and we'll say examples. Add CFFI example as well as align as attribute. As well as 1 for, yeah. Ooh, one thing I would like to do, since people don't necessarily know how to do things. I forget that sometimes, right? Compile like cc code.s cffi.c. Where code.s is assembly generated by intercept compiling cffi.int, and cc refers to a working C compiler. To a working C compiler like GCC or Clang. I think that, is this readable, chat? Does this make any sense? Would this be instructions that you look at this and go, oh, okay, this makes sense. Compile like cc code.s cffi, where code.s is assembly generated by intercept compiling cffi.int, and cc refers to a working C compiler like GCC or Clang. I think that makes enough sense for somebody digging around in examples for intercept. We're going to call it good. King Bun says, yeah. CalcMath says, yes, makes sense. Legendary, thank you so much. It helps a lot to get a second opinion with stuff like that, because I'm not sure what it sounds like necessarily. I try and write clearly, but at the same time, I'm great at overcomplicating stuff. Oh, I already wrote this. And that's that done. We now have some good examples. Well, I don't know if they're good, but we at least now have some examples. Fog champ. And then in to do, I guess we now have attributes done. So where add a nomangle attribute, done. Attributes. Parsing, done. No return. Ooh, that would be a fun one. Discardable, opposite of no discard, which it has to become the default. So that's going to be in Sema, where we now enforce no discard. Interesting. Okay, so that's going to be something that we can work on next time. Ooh. Is definitely no return and no and discardable, and enforcing no discard being the default. So doing these would be some great attributes. That also helps a lot in general in the language, because it will mean that it's much harder to make an error where you accidentally ignore a return value of a function. And then it'll also make it better because no return will be understood by the compiler, and we don't have to be silly and like pretend we're going to return when we aren't. Well, Sarade, don't I wouldn't say no, because they might be talking about like constant folding. We do constant folding. Yeah. We don't support compile time execution of arbitrary code, but we do support compile time execution of a subset of the language, which mostly has to do with like literals and inlining them or using them directly. Can you implement time travel to previous code states? It's called Git. That already exists. I mean, you don't have to invent it. It's just hash the file, compress its data, save changes. So it says, apart from simple constant folding and strength reduction. Yeah, exactly. CalcMath says, I meant like almost meta programming, but const folding is good. Yeah, metaprogramming style, we haven't really, I'm not going into that because I want to get the programming right first and then go into metaprogramming, right? Facebook did that too. They waited before they went meta. And I think that's a good business model. Facebook's a big business, you know? And, but yeah, as for metaprogramming, we absolutely are going to have like macros and stuff like that, where we have code that generates code. I'm a very Lisp heavy person. And having code that generates functions, I think is going to be a large part of that. But again, that's the upwards funarg problem, and I haven't solved that in this language yet. But I'm gonna. That's for the way future, though. We've got plenty to do in between then and now. Like actually, you know, implementing all of these attributes, padding string literals to ensure alignment of statics, really just ensuring alignment of statics in general. This type of thing. Handle size. We're definitely doing this in the back end, but we haven't updated the IR parser, so that's a problem. What else do we have? Slices, dynamic arrays. That's right. That's right. Slices or dynamic arrays are two different things, kind of. Because a slice, I want to be able to take a slice of a static. CalcMath says that's a long to do. Yeah, there's lots to do. There are lots to do. We've done that one. Hooray. Walker Code says, I heard Lisp heavy and had to check. Nice to see another Emacs user. Absolutely. I love Emacs. Emacs is my baby. I love it so much I made my own. A slice is typically non-owning and a dynamic array is typically owning. Yep, that's it. You just defined it exactly, Saraid. You defined it exactly. Rosux, is the language going to be typed or not? You must be new here. The language is typed. It's statically typed. It's a compiled language as of now. It's a statically typed language and pretty much always will be. There is type inference, right? So if we look at the SDL example, you can see that we don't actually have to define like SDL event quit is an integer equal to OX100. We can just say SDL event quit is OX100, figure out the type. So there is type inference, but it's statically typed. We may make an interpreter at some point. There's no reason it has to be compiled, but statically typed is something it's going to be. Speaking, have I showed the SDL2 example working on stream? I don't know if I've done that. It's a larger program. Yep, that one. Are you ready, chat? Oh, Pog. We got our SDL tutorial, our little window. It works. It works. But yeah, so we're getting there, you know? Sorry. Rosix says now resize it. We don't pass the resizable flag, so we can't. SDL2, when you create the window, has flags, and we don't pass the resizable flag. We pass 0, which means it's not resizable. We'd have to go and figure out what SDL resizable flag is actually equal to, and I don't want to dig around in SDL source code right now. So it says the speed of that AST printout was a certified KC Muratori moment. Yeah, it's a bit slow, you could say. You can literally, it's POSIX. You can literally see each line get printed out. It's better than like Pokemon, though. It's a little faster than Pokemon. That's what I'm going to start telling people. The Windows terminal is a little bit faster than Pokemon when you hold the button. Oh, that's so dumb. You know Pokemon when they like the text is on screen and you hold the button and it goes faster? It's this fast, right? Or like in Super Mario 64, you know when the bubble comes up and you're just like da 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 da. CalcMath says lol, you mean like in the emulator? No, like in Pokemon, like the games. I'm picturing like Game Boy Pokemon. I don't know what the new Pokemons are like. I haven't played them or seen them. Pokemon that I played like 10 years ago, right? When someone talked, they would have like text come up character by character. It'd be like and if you held the button, if you held like A or whatever it was on the Game Boy, it would go and it'd go like as fast as this does. It'd go this fast. And you could skip it and it'd go. It's slow, is what I'm saying. Calcmass says, yeah, sorry, I thought you meant playing Pokemon in an emulator on a PC. They have a fast forward button. Yeah, nothing like that. I do... I'm gonna stop talking. Now you just need your terminal to beep for each character printed, because that wouldn't be annoying. That's a good idea. Have every character have a /A in between. Beep. Just do a bunch of those. Lamau. Oh. Uh-oh. The numbers. Can you... Hopefully everyone can still hear me. Hate terminal bells? You'll love this! Calcmath earlier said, ooh, that's like Jai syntax, poggers. Oh, that was probably the SDL2 stuff with the type inference. And technically you can do the same thing with like functions. It just becomes a lambda expression instead. Having no mangle on a lambda doesn't really work, which is interesting. Just something to think about. But we do allow it currently. Oh God, I'm dying. Okay, what are we doing? What do I think I did it is the problem. I've done it. Yeah. Function bodies must be blocks or preceded by equals. I feel like this is a good idea to add. Walker Codes, thank you so much for the follow. I appreciate that so much. So much. But yeah, so we've done it. We have implemented attributes, including align as. We've got the align as attribute. And then we also have function attributes, mainly no mangle, which means that, for example, in our CFFI, we can have sum2impl be no mangle, and that way in C, we don't have to call whatever that craziness was before, right? We can just call sum2impl itself, and in the generated code, that is what will be shown. Oh, that's the SDL code. I need the... What was I just looking at? CFFI. That one. And if we take a look here, you can see it's actually called sum2impl. And that's what it is exported as. Coolio. Calcmath says, nice. I love easy interoperability with C. That's pretty much the only thing you can do in Intercept right now. is nice interop with C. That's kind of all it is. All of our tests do like prints with put char, you know what I mean? It's basically just a language on top of libc. Which is nice because the compiler is written in C and only relies on libc as well. Which means, poggers, all you need is a C compiler, a working C compiler and a working C library, and any intercept program should be relatively easy to run. And most of the time they're just freestanding. One thing I did want to do for intercept is have a syscall built in, but I'm not sure if I want to have that like, what exactly is .s assembly format? I don't know how much you know. It's the GNU assembly syntax, which is gas. And that can either have .s or .s, right? Gas, aka GNU assembly syntax, yeah? GNU assembly syntax is just AT&T assembly syntax, but modified. Yeah? So GNU assembly is AT&T assembly syntax, right? And AT&T is literally just a company that made their own assembler, and that's the syntax they used, something like this, right? And we've stolen it. So AT&T has, for example, percentage signs before every register, dollar signs before every constant, and you can put parentheses around anything to dereference it and actually treat it as the memory address rather than the value. So instead of moving the value of RCX into RDX, we move it into the memory where RDX points to, which is how we do a store, right? And then the other big thing about AT&T or GNU syntax is that it's left to right. So it's source dest. So you move things from the left into the right. It is not like an assignment, right? Right now we're saying like pointer to RDX is equal to RCX is what this is doing. So you can see basically RCX is moving into the memory at RDX, right? Hopefully that makes sense. So in Intel syntax, it's actually destination source, and it's a little bit different. So it would be something more like this, I believe, in Intel syntax. And then you'd have to tell it how big of memory to actually write here with like querd. But it's all x86 64, right? Yep, this is, it doesn't have to be, but yes, this is x86 64. There can be gas that isn't x86 64. There can be gas for lots of different things. But the most common that's used, just the most common architecture is x86 64 right now for desktops and personal computers. So that's what generally gets generated, and that's what we generate. The plan eventually is to skip assembly and just go straight to an object file. That way you can use it directly in the linker and you don't need an assembler to actually do anything. But all that means is that the assembler moves into intercept, or the x86 64 backend specifically. Yeah, hopefully that makes a little bit of sense. This is, Saraid brought up an interesting thing that I always forget as well. In case you don't know that, the difference between .s and .s is that you can use the C preprocessor in .s files since they'll be pre-processed. That's right. That's very right. So if we had like some C code, not even some C code, we could emit in this file, define foo bar. And then anytime you see foo, it would actually be bar. And that would work. We don't take advantage of that, but I just called it .s because there's really no reason. I don't think when I named it I could remember the difference. So it says, oh, I missed a question. What flags were you compiling the SDL example with? What flags where? For intercept, it's just print the ST, debug the IR, annotate the code, and verbose. If you're asking about the slow printout. If you want, I can time it too. There you go. 3.5 seconds. And if you're asking about the compilation, I just passed -L to the /lib of SDL2 release that I downloaded. And then you just link with SDL2. We don't need SDL2 main because we don't have WinMain craziness going on in our programs, luckily. I'm thinking about doing that for LenserOS and having a custom entry point for programs, but I don't know. So it says, I put a video in off topic. Okay. This is the speed you'd expect from a terminal. It's instant. It is absolutely instant. That was incredible. Can you time it? You don't have to make a video of it, but can you time it? I'm just curious to know actually how many orders of magnitude faster it is, because it's way faster than that. CalcMass, so right now there's no way to run it on other architectures. Correct. Or can the assembler and the C compiler magically cross-compile? I don't think you can cross-compile. Well, you can cross-compile. It's just going to be a bit odd. No, I don't think you'll be able to. I'm trying to think about how the internals of GCC works. So if you actually have a cross-compiling GCC, then I don't think it would be able to do this. So you could cross-compile it to different OSs, but you can't cross-compile it to another architecture. But all you'd have to do to support another architecture is go into the source code of Intercept, go into the code gen, make a new backend, right, like x86-64 does, and then just define a few functions, namely codegen lower and codegen emit. If you implement these two, and also parameters in register, if you have register allocation or not, you're going to need this, I think. But you can just always return false or whatever. It doesn't really matter. As you can see, you just define your own backend, which defines really mainly these two things and a codegen context create and destroy. So there's like 4 functions and you have your own backend and then you can do anything like that. Maybe you can disassemble it to C, then compile it back, lol. I mean, there'd be no reason to do that. You would just write another backend, because the backend isn't the complicated part. It is 2,000 lines, I hear you, but it's not the complicated part, I promise. Like, porting this to, like, RISC-V wouldn't be impossible. I didn't know it was that easy. I mean, it's not easy. I'm just saying, out of everything in the compiler, adding a new backend is one of the easiest things I could do. Because it doesn't require changing anything. It just requires filling in, like, oh, when you have an add instruction, what do you print out into the file to make an add mnemonic? You know what I mean? And it's just kind of that forever. It's not too difficult. And then you just have to emit the assembly or whatever. If you want to, like, emit machine code, it is, I'd say that's hard to make a machine code backend or an object file backend. But to make another architecture, you would just have to translate it into something that is compilable to that architecture. So you could do assembly for that architecture. You could compile it into C code. You could do whatever, really. Honestly, it would be pretty easy to make a C backend that just transpiles into C. Because loading and storing and oring and anding is kind of all stuff you can do in C. The hardest part would be like lambdas. But even then it'd be easy because the IR makes that trivial. If there aren't equivalent instructions or there are better instructions for a scenario, then it gets more complicated, right? Maybe. There's no case we have where there aren't equivalent instructions, really. Like we can look at MIT, wherever it is, right? You can see that like in our intermediate representation, here's the types we have. None of these are really not matched by an instruction or anything. Immediate, call, load, return, branch conditional, unreachable, phi doesn't map to one, but it's just for register allocation and value gathering mostly. We have copies. We have the binary instructions, add, subtract, multiply, divide, and, or, not, etc. Not, because it's not a binary. It's a unary. These are just variables, right? Static ref, func ref. These are just function variables or static variables or what have you. We have zero extend, sign extend, and truncate, which, I mean, isn't too difficult. It's not going to be easy, but it's not going to be difficult, right? In C, those are all things that are doable. Bit cast, quite easy, just a cast, store, not parameter. Parameter gets lowered out. And then these aren't actually generated. These are just used for other things. So really, there's only 20 or so things you'd have to translate, and they're all very simple, well-defined things. The hardest part would be phi nodes, but that would actually be pretty easy because you can just use a variable in C that is defined before all of the, like before the earliest phi argument. I see it's from this IR to the arch-specific instruction. Yep, and that's what arch x8664.c does. It takes these instructions, like a divide, and then emits a register-to-register move from the racks register. And then we do a CCO, convert quad to octal word, convert quad word to octal word, which is just 4 to 8 bytes. And then we do idiv and move the result into the result register. Walker codes, I'm slowly catching on. Is this LLVM or homebrew? Homebrew, completely us. We did all of this. Quad to octal word is 8 to 16 bytes. Thank you, yes, words are 2 bytes, I forget, in this scenario. Because a double word is 32 bits, and yeah. You are right, it's 8 to 16. I messed up. CalcMath, oh, I thought you meant like the Mac homebrew. Yeah, it's not a, we don't use the homebrew package manager at all. So technically it's not homebrew. Walker Code says, very cool. This is the side of computing I have so little context on. Also, since you were asking about orders of magnitude, check off topic. Oh, legendary. Oh, legendary. Now, this is a Windows moment, okay? Is that 3 orders of magnitude? That is, right? 3 to 0.3, 0.03 to 0.003. That's 3 orders of magnitude. So Windows Terminal is 3 orders of magnitude slower than it should be. Literally 1,000 times slower. Hey, Calc Math Gent, welcome to the welcome to the Discord community. We love to have you. I hope you have a great time here. That is hilarious. It's literally over 1,000 times slower. Oh, that's so bad. And this is in Windows Terminal. Imagine CMD. CMD might be faster. I just can't time it. Because you know how Windows avoids the problem of being slow? They just don't include time. Time just does not time anything. It doesn't do what you think it does. New Shell includes time it, and that happened in like 0.75. 0.6 apparently. Lamau. As far as I know, command is slower, but who knows? That'd be crazy. I don't know. CMD seems like it'd be faster because it's simpler and doesn't handle as much stuff. I hate when this happens. I can't get the pop-up to go away. Gent TV says, I'm 1 hour into your making a compiler from scratch in C1. Oh, cool. You're only like 8 days away from where we're at now. Cool. Walker Codes, this is the side of computing I have so little context on. Well, if you have any questions, let me know. Because I make an OS, I make a compiler, I make a text editor. Those are all things that put me very deep in the weeds, if you know what I mean. Right? It's not easy. I mean, it is easy. There's nothing I do that's like, oh, how could you do that? That's so hard and to pull off. Like, I'm not doing skateboard tricks. You know what I mean? It doesn't take... It's just like there's just large things take long times. That's what... You can quote me on that. Large things takes long times, okay? You hear that? That's wisdom. Large things takes long times. And when they does, it's rough. But it's not rough. Like walking isn't difficult, but walking 20 miles is. That's how I'm gonna say it. Walker Codes. So what I'm hearing is kickflips are about as hard as compilers. Gent TV says, I don't understand much yet, Lamau. I only learned some C through CS50, but it's still so interesting. I'm glad you're interested. That's all that matters. But I promise you, you can understand. You can do it. There's nothing here that's like magic. Like a kickflip, right? I'd say kickflips are easier than a compiler, to be honest. Because a kickflip, it's just like practice. I mean, it's not just practice, but it is just practice. I can't kickflip, but I know that I'm practicing, so I will eventually, right? Building a compiler is like making up a new trick. It's like, unless you're just following a tutorial or doing something that like you're not making it up yourself as you go, in which case you're not like making up your own trick, you're just doing a kickflip. In which case I'd say that's as hard as a kickflip. But the fact, if you just like start from scratch and go, I'm gonna write main.c #include standardIO.h hello world, right? If this is your goal to start here, if your goal is to start here and make a compiler, you've got a rough time ahead of you. I'm kind of scared. There's a clip. Do I click it? Oh no. Oh no. Large things takes long times. Oh, that's so dumb. That's beautiful. I can't save it as a highlight till the stream ends. Also, I don't encourage these people. No. Is she sleeping? Get out of here. We're writing compilers here. You can't be sleeping on the job. I'm disappointed in whoever that was. AnnOSRS says, what if I'm starting there but want to make an operating system? Well, I mean, you can. That's kind of LensorOS. I used a tutorial for LensorOS because OSs are much more complicated than compilers, and not having a tutorial to start is just requires you to know things, which I didn't at the time. Sorry, I love how my meme popped up again, if ever so briefly. AnnOSRS says, streamer believes in me, heart. I do believe in you. Anyone can make an OS. And if you have any amount of motivation, then you can definitely make an OS. Because most people go, an OS? I can never make that. If you feel like, maybe if I work and I learn and I follow a tutorial and I try it, and maybe I can do it. You can definitely do it. How do you even write a compiler? Like this. You use some other language and make your language. You start with lexing and stuff, right? It's quite simple. You start with like splitting up things into tokens or whatever you want to call them, lexemes. And that just requires a parser, right? I want to make one, but I suck at programming. I've got good news. I also suck at programming, and here's a compiler I've made. Calc math. So that's why I first implement Lisp in C, then use my Lisp for the compiler. So technically I implemented a compiler in C then. How would you even stay motivated on a massive project like an OS? So that I can do this. In Electri, if you're asking that, the answer is you probably wouldn't. I'm not trying to be mean, I'm being honest. It's been over a year that I've been working on this, and it's not like I haven't wanted to give up, you know? It's really hard. But to see this happen and know that, oh, I did this, and I implemented this, and this is a shell that I made that works in an OS I made. And we even have like ARP packets being sent. This is a virtual MAC address I figured out, by the way. But we even have like ARP packets being sent through the network, and we have a shell, and we can have a server run in the background, and then have a client run in the foreground and connect and read from it and write to it, and then disconnect from the server, and the server can detect that connection, it can accept it, it can write, and we can get 69 and 420, right? Oh, poggers, right? It's just so cool. And this doesn't do anything yet. AnnOSRS says, that's so damn cool. Electri says, that's amazing. King Buns, blaze it. That's how. Exactly, blaze it. But yeah, I'm glad you guys all think that's cool as well, because that's what keeps me going, is I think this is so cool. Like, I can type anything here, and it will echo it. Isn't that, it's crazy. And it's running a new process, and it's forking and execing and processes and page tables and file descriptors and, syscalls, everything. Having it all work together, it feels like I'm making food. Like I've got to cook the pasta, and then as it starts to soften, I've got to heat up this milk so that the sauce will be ready at the right time. And it's like this entire cacophony of stuff going on and chaos that ends up in this actually working product somehow. But yeah, so there's not a ton going on in this yet, obviously, but it just makes me so happy. And with sockets set up how they are now, we can actually implement a GUI protocol where I can start up a Windows server, and then actually I'm going to be able to have each GUI program be a client of that Windows server, and then anytime a request is incoming, the server will respond to it and deal with that particular client's request. And yeah, should go well. So pretty soon we're going to have a GUI with like windows and mouse events and keyboard events. Very soon, honestly. It's next 6 months. AnnOSRS says, the good news is I'm only 27, so I have plenty of time to learn. Yep. AnnOSRS says, implement RDP streamer. I don't know what that is. CalcMath says, to truly understand something, you need to be able to break it down and put it back together. Exactly. Yes. This is like the software version of it. It's exactly the software version of it. I can Eletri asks X. What are they asking about X? The X Windows server? Is that what you're asking about? Not the X Windows server. There are no ports to LenSR yet. It is all proprietary, well, open sourced, but it's all like written in-house. Yeah, not the X Windows server. We're not going to support the X Window protocol. It's not going to be like the inherent window system or server. Everything is going to be in user space as far as the Windows server and stuff like that. So it can be anything. The user can run a different Windows server if they want, and then have GUI clients connect to that. And yeah. Saraid said, what do we have? Oh, implement RDP streamer. I still don't know what that is. I'd probably start with something like SSH Lamau. SSH wouldn't be too difficult once we get actually like a user space way to send a packet. Which effectively is just implementing a new socket type in the kernel, which we'll get there. We'll get there. They're probably talking about remote desktop protocol. I've never heard of that. That does sound cool. At least that's the only RDP I can think of. That would definitely be cool. I don't know what it is, but it sounds cool. It's probably just a way to like send your screen to somebody else. Yeah, because it's a streamer. It's basically Microsoft Windows SSH. Ah, so they have the like, doesn't Windows SSH do like it's like Windows specific VNC. I don't know what VNC is. There's too many, I don't know what's going on anymore. But yeah, start with parsing or start with lexing into tokens, right? So you say lex the token. If you get a 0, it's the end of the file. If you get a left paren, it's a left paren. If you get a right paren, it's a right paren. If you get a colon and then an equals, it's a colon equals. If you get a colon and then a greater, it's a colon greater. If you get a semicolon, yeet the semicolon in it. Maybe line comments if it's a line comment, right? Eat to the end of the line comment. But the lexer will just break it up into those tokens. And then in the parser, each time you get a token, right? Parse expr with precedence. Each time you just say, okay, we have some sort of token in the parser. And what is it? If it's an identifier, parse an identifier expression. If it's an integer keyword or byte or void, then that's a type. So parse a type expression. Hopefully that makes any amount of sense. Saraid says, too many acronyms? Networking moment. Pretty much. AnnOSRS says, is this your own language you are making? Yep. It's called Intercept. This is what it looks like. Or this. Or this. Or this. But yeah, there you go. That's where we're at. This is the C source code that implements that language. AnnOSRS says, language does not look like C#. Brain cannot handle. AnnOSRS, what does the arrow mean? What does the right arrow mean? Like here? In the C code? Do you know C? Do you know what a pointer is? If you know what a pointer is, I can just give you a quick explanation. If you don't know what a pointer is, I don't know if I'll be able to help you. AnnOSRS says, yeah. No. Yeah, no, That's my favorite. I kind of do. Let's do this. Yeah? So a pointer is a memory address. Okay, so you're getting there. You're getting there. So let's say we have an int foo. To get the address of foo, we can say, okay, get me an int pointer called foopointer equal to the address of foo, right? CalcMath says pointer primer. Let's go! It's not a reference to a memory address. That'd be a pointer. AnnOSRS, so a pointer is a memory address. Sure. So this integer is somewhere in memory. We get the address of it and get a pointer to it, right? And I'm sure what you're familiar with is that you can take this foopointer and assign 42 to it. What happens here? Why is this important? Why is this important? What happens to foo when we do this? We have a pointer to foo, and then we dereference it and assign it a number. AnnOSRS says because you can pass by reference. What? No. Has nothing to do with references. References don't exist in this language. We're in C. There are no references. I understand what you're saying, that when you pass a pointer to something, it's like passing it by reference, but it's not passing any reference or anything like that. AnnOSRS says you can change it inside the method. Sure. So what you're experiencing is that this foo pointer can point anywhere, right? We could also have int bar, and we could have this putter point to bar. And this is still valid, right? We can still assign 42 to putter, but this time it's bar. And then here's the confusing thing. We can do that twice. AnnOSRS says that's what they said it was for. Okay, I'm literally a computer science dropout, Lamau. Yeah, pointers are not for anything. That'd be like saying flour is for making bread. Yeah, it is, but it's also for making any type of dough in any shape or form, or also making roux for sauce, or also bechamel, or it's like limiting it way too much. So what happens here? Does foo equal bar? Actually, what does foo equal? What does bar equal? Right? What's happening here? We have an integer and another integer. We have a pointer, which is the address of foo, and then we dereference that pointer and assign the dereferenced pointer to 42, right? We assign to pointer dereferenced 42. We then assign pointer to the address of bar. We dereference pointer and assign 42 to that. So when we dereference a pointer, what actually happens? We no longer reference the pointer itself, like we do here. We reference the value that the pointer points to. Yeah? So you can have foo somewhere in memory, right? You can have pointer, which points, right? Points to foo. But you can also have pointer, which points to bar. You can have pointer point to anywhere, right? Any integer. You have foo. You have a putter. Putter can point to any integer. So when you access putter, refers to the memory address, star putter, refers to the value at that memory address. Yeah? So something is like the value held by the mem, right? Wait. AnnOSRS says foo is 42. No idea. What? It's confusing how that's confusing. I'll simplify it. What is foo? We create an integer foo equal to 69. Foo is 69. Gent, that's very correct. A pointer is a variable with a memory address as the value, right? That is exactly right. That is perfect. It is just a variable that contains a memory address. The variable has a type underlying it that you can access by dereferencing. So if you take an int pointer and dereference it once, you get an int. See how that makes sense? So int pointer dereferenced once is an int. Yeah? So you take this and you subtract it, and that's what happens when you dereference it. Yeah? So you dereference the pointer and you get an int. So here's the confusion. Putter is an L value. L values can be assigned to because they have a memory address. Yeah? So star putter is an L value because it's dereferencing putter, and the L value, the memory address that it refers to, is actually the memory address of the thing it points to, right? AKA its value. Makes sense? So when it's on the left-hand side here, you can say whatever it's pointing to, the memory that it's pointing to there is now pointing to 42. What is an L value? We'll get there. So with this, we dereference putter, we get an int, and the int is wherever in memory that pointer pointed to, right? So the 4 bytes of integer are somewhere in memory, and they're pointed to by putter, which is foo. So the address of foo, right, and foo is being equal to 42. When you dereference the address of something, it's the same as just using it. Yeah? So that's the same as doing foo equals 42. Does that make sense? I feel like bringing up L values when you're still explaining pointers is a bit early. I didn't bring it up to explain it. I just said it's an L value, which means it has a memory address. I don't think that's complicated because pointers have memory addresses. And we're talking about getting the value at the pointer or the pointer itself. Just Chill says, let us digest. What is foo then? All you have to answer is, after this, what is foo? Is it 69 or is it 42? You guys look at that. I'm going to be up here doing something. It's kind of a mess. Sure. Don't worry about what I'm doing if you are. This is the great C hurdle. It's super confusing before you understand it, but once you get it, it becomes very easy and obvious. Pretty much. Just Chill says 42. That's correct, Just Chill. Sarade says, anyway, I have a double pointer meme if that helps, lol. Or two, actually. That does. Well, check them out. Feel free to drop them in off topic. Sarade says, you can probably do dashes for a line. That's true. I don't really care. It'll be the same. Yeah? Okay, AnnOSRS says it's 42 because foo is 69, yes. Then we make a pointer, yes, which is a pointer to an int, very correct, and set it equal to foo's memory address. Oh, that's beautiful, AnnOSRS. Then we turn putter back into an int and assign it 42. That's close enough. You are correct. That is what's happening here, AnnOSRS. You got it. Walker Code says now time for double and triple pointers. Oh god, no. AnnOSRS says, I need this guy's color scheme for my VS lol. It's all on GitHub in my Emacs files. So you can get my Emacs.files, and in here I'm using the Lenser theme. And here's all the colors. Just so you know. I put the 2 in off topic, legendary. This is a kind of well-known one. Int pointer pointer, int pointer, int. Just literal pointers. Yes. Yes. We're not going to talk about double and triple pointers yet. But yes, this is correct. Don't worry about it. I want to talk through this. Sarade, those are correct. AnnOSRS, yay, I did it. You did do it. So here's what you can think of, right? The computer's memory is just a big array of bytes. Each number in the following line is a byte. Yeah? Each number in the following line is a byte. Each of these bytes, right? We have one big head array. List of lists, evil. Even just a list is a pointer is used for. It depends on what you have a list of. And whether it's heap allocated and stuff like that. Either way, each number in the following line is a byte, right? So you can picture this array as your memory addresses, right? Here's memory address 0, here's 1, here's 2, here's 3, here's 4, here's 5, here's 6, etc. Yeah? This is big endian. I don't know why I did it like that. Don't worry about that part. An integer, I'm sure as you know, is 4 bytes on modern systems. So these 4 bytes refer to foo, an integer. This is where it's been allocated. This is its memory address right here. So this memory address could be thought of as index 2 into this array of bytes, right? Index 2. Yeah? So when we access foo, we get 69 because it looks at the 4 bytes at foo's address and says, okay, this is a big endian integer. We have 0 bits, 0 bits, 0 bits, 69. 69 is the total value. Pointer equaling the address of foo is equivalent, like putter is now equal to index 2. It does not equal 69. It does not equal the name foo. It just is a number 2. Yeah? So, that is funny. So this number 2 just refers to this 2, and that's it, right? There's nothing more. Pointer is now equal to 2. And that's what they mean when they say its value is a memory address. If you were to access putter in this way, you would get the number 2. It's going to be an int pointer as a type, but its value is going to be 2. It equals to the address in memory of foo. Exactly. And in this case, foo is at 0, 1, 2. Right here, right? How does it know where 0 is? Haha, think. Right? Because 0 is 0. And the address of foo could be 0. It just usually isn't. So foo, address of foo is equal to 2, right? So now pointer equals 2. But what's actually happening when we do foo equals 69? Foo is a variable in memory, right? And its memory has to be updated with some value. Yeah? So we actually look at the address of foo, and then we assign it 69 by doing a dereference. We get the address of foo, right? But we don't want to set the address to 69. We want to set the int at that address. So you can see we dereference the address of foo. And what you'll notice is that dereferencing an address is the same as not taking an address and not dereferencing, because they cancel each other out. So foo is just equal to 69. Does that make sense? So here you're just doing a pointer dereference that's hidden. You're getting the address of something called foo. You're assigning to it using a dereference. Yeah? When you're doing star putter, you are doing that exact same thing, but putter is actually equal to and foo. So there is no longer a canceling out effect, because guess what? Star and foo doesn't equal a putter, it equals its value, right? 69. So putter equals and foo is way different than star putter equals 42, because putter equals and foo, right? You can replace this with and foo, because a variable is just a replacement by its value. And we know that when we dereference the address of something, we can also just not do that because they cancel each other out. Foo is equal to 42. Hey, that's exactly what this does. Isn't that interesting? So that's how we know foo is 42. AnnOSRS says, that's insane. I've never thought of that like this. I'm glad I can help, because this stuff is important. This is like C in a nutshell. Now, the tricky part gets, right? Which one? That one. The tricky part becomes, what about when we have bar? Bar is equal to 0, right? Bar is up here now. This is bar. So accessing bar will get 0. But this pointer, here, okay, before we even go to bar, I'm not even going to start on that. I'm going to start on this. Yeah? Gent TV says that's a really nice way to think about it. Legendary. I'm so glad I'm not just spewing nonsense, because it feels like that. Putter. Putter is equal to null. There's zeros here, because what we can forget is that putter is also in this same memory. So putter has a putter, yeah? Putter has an address where we can access its data. Right now it's null, but we can update putter to be the address of foo, right? And just like before, this is equivalent to dereferencing the address of putter. See, this works. This is fine. This is what it's actually doing. You just don't write the two that cancel each other out, where you get the address and then you dereference it. You don't need to do that, because that effectively gets you the same value that this does. Putter is equal to the address of foo. What that does is it goes, again, it's dereferencing memory, so it stores in memory 2, because the address of foo we know is 2, yeah, 0, 1, 2. And in putter, that's the number we store. Again, big endian, don't know why. Just for this example. So now putter is equal to 2. Yeah, hopefully this is making sense. And then we can dereference putter. And when we dereference putter, we'll get 2. We'll dereference that. And the memory address at 2 will be treated as an integer. And we'll assign 42. Yeah? Pointer arithmetic and arrays can also help solidify some of these concepts. That's true. I didn't want to get into pointer arithmetic because it's confusing, but that's a good idea. But you can now take putter and assign it to bar. And then you can dereference putter once more in the same way. But this changes, right? So we start out with something like this, where we have foo, and then we have putter, right? But then we can imagine after here, also this is in the wrong spot, my bad. But then we can imagine that before the second dereference, we actually have foo putter, and then somewhere else, we have bar, right? Bar is somewhere else. So let's just expand our memory a little bit. And now we have bar, yeah? And bar is actually at offset 14, I believe. So now putter is going to equal 14. And because that's the address of bar, and when we dereference putter, we see 14, we get that memory address, that's here. And then we treat those next 4 bytes as an integer, because pointer is an int pointer, and then we assign 42 to it, which means that this will end up as 42. A lot of stuff happened. Is it just... I just feel bad because I'm miles away from attempting C. Nah, just go write code. There's no one stopping you. You can go attempt C right now. There's this wonderful Godbolt thing, which is a compiler explorer and really helps. You should check out Godbolt if you like it. But you can just make like int main, right? Oh, don't do what I just did apparently. You can make an int main that returns 69. Right? Nothing here is too complicated. And you can look at the code that it emits and see, oh, here's the assembly. And you can do in reasonable syntax if you want as well. Just chill, so send it in chat, please. I just want to bookmark it. You got it. But yeah, so this can help you and when you hover over things, it shows you what is doing what, and you can get it to explain what each of these is, and stuff like that. Sarade noticed. Sarade noticed. But yeah, hopefully that makes any amount of sense. What did we have? Electree, so if you did int bar equals star putter, that copies the value, right? Great point. So because this is an L value, it's both a memory address and a value, which is what we were getting to earlier. But yes, we can also do int baz is equal to star putter, and this retrieves the value at that place rather than sets it. So in this specific scenario, this star putter L value acts as its memory address, and in this particular scenario, the star putter L value acts as its value at that memory address. Because you can picture like an L value as like a void pointer address, right? And then the actual value. So like, let's say this is an int L value, then there's be an int. So you have address and value, both available. It's more of a union, and if you don't know what that, don't worry about it, but think about it like you have both of them available. You can either get the address or get the value. It depends on what you're doing, which is why in this scenario, we get the address, that pointer, right? We get the address of this L value. We don't actually say 69 equals 42, because that just doesn't make sense, right? Because if this got the value, then this would just be 69 equals 42, and what does that mean? Right? So in this case, we get the address part of the L value, and in this case, we get the value part of the L value. Gent TV says, so what's an L value? Well, it's what I just described. It's quite simple. It's kind of just this. It is a thing, X, that has both an address and a value available. Is 4 an L value? Does 4 have a memory address? It's like a node in a linked list. No. It's something that can be to the left of an expression. That's very close. It's something that can be on the left of an assignment expression, but yes, that is true. That's not its literal definition, but yeah. Is 4 an L value? Does 4 have a memory address? When you type 4 in C, this is a thing, right? 4 is a thing in C. You can do like 4 plus 4. Does 4 have a memory address? Can you do and 4? Can you get an int pointer foo, like numputter, and equal to the address of 4? So it says, I wouldn't really call L values simple as a concept. Well, calling something not simple doesn't help people understand it, but I agree with you that they're not. Roosterhead says, identifiers can start with numbers, right? No, they cannot. They can't start with numbers. That's correct. So what is this? Why doesn't this work, chat? 4 is an int, right? What's the type? What is the type of 4? What is the type of foo? I know it's kind of hidden, but here's foo and 4. Eletry is what happens when accessing unfocused data is a union decided by the compiler. No, I don't know what you're asking, but the answer is no. Roosterhead, Just Chill, and Gent all say no, no, no. So you cannot do this, right? That's what they're saying. You cannot do this. Why not? Why can we not take the address of 4? Why does it not have an address? Isn't it the same type as foo? See, Just Chill is understanding now. Just Chill is understanding. Foo is an L value, and 4 is something else. I don't know what it is. Beautifully said, Just Chill. Beautifully said. You'll see why. Gent says, because 4 by itself doesn't have an address. It's not a variable. Mm-hmm. You just said it. You just said it. That was beautiful. So, right? Let's go over what Just Chill said. Foo is an L value, and 4 is something else. That is correct. So we know that foo is an L value. Yeah? And 4 is not. Because foo, we can get the address of it, and 4, we cannot get the address of it. Right? So even though int foo equals 4, right? This is allowed. 4 is an integer. As far as C is concerned, the literal 4 is an integer. It's an int. These are compatible types. No cast required, right? We don't need to do int from integer literal. It's an int. 4 is an int. So what is the type of 4? Int. What is the type of foo? Int. Well, that's confusing. right? That's very confusing. Because if these are both ints, why can't we get addresses to them? And the answer is that, first of all, we know foo is a variable. Variables are allocated in memory somewhere. How does the OS handle it then, the for thing? We'll get there. Foo is a variable. Variables are allocated in memory. Therefore, it stands to reason variables have a memory address where they are located. It's literally this simple. I know it seems confusing, but it's just follow me here. Foo is a variable. Variables are allocated in memory. Variables have a memory address where they are located. And one thing we can look at in the compiler explorer is exactly that. What is the difference between int foo equals 69 return foo and return 69? Let's take a look, right? So you can see that in assembly, there is something called a base pointer on the stack, right? So we're basically moving 0 onto the stack. That's just for funsies. I don't know why we're actually doing that. Don't worry about that. We move 69 onto the somewhere off the stack, right? Then we move somewhere off the stack, this memory address. See this, right? We get some memory address and we move the data there into EAX and then return it. That's it. We move 69 somewhere in memory. We move somewhere in memory into the return value, and then EAX is the return value, so that's what gets returned. Program return 69. Yeah? So somewhere in memory, we store 69, and then somewhere in memory, we retrieve that number, which happens to be 69 because that's what we stored there last. It's like a bucket or a box that you put things in, right? But if you just return 69, you can see that there is no memory address. It just moves 69 into EAX. So there is nowhere in memory that stores 69. 69 is simply stored in a register, never in memory. Because it's never stored in memory, this program is faster. But because it's never stored in memory, this variable doesn't have an address. So 69, no matter where it is, doesn't have an address. Because even if we do this, int foo equals 69 return foo, you can see that foo actually gets an address, which is -8 off the base pointer. Don't worry about what that means. It's somewhere in memory, right? And then somewhere in memory, we can load that value. I hope that's not too complicated. I know it looks complicated, but don't get distracted by the specifics of, I don't know what movel means. Just think about it. You take 69, you put it in a box, you take something out of the box, and it happens to be 69 because that's what you put in there last. Yeah? This is an L value, foo, because it has this memory address, -8% RBP. Even if you don't know what that means, this uniquely identifies foo. If we had bar, you can see that it's -12 RBP instead of -8. So this is some unique identifier, some unique box where we can put something. And you can tell that if we were to change that to 12, we will return bar instead of foo, because we are loading from somewhere in memory. Gent is correct. Memory allocations are slow. That's not what they mean when they say that, but so that's why returning 69 right away is faster. It's faster because there's less instructions. RAM is slower than CPU memory, exactly. I mean, CPU memory is RAM, but I know what you're saying. Hopefully that makes any amount of sense. You can create a box to put something in and put something in that box, and then anytime you look in that box, you'll get whatever you put there last. Yeah? The box has a label. Just Chill says, can you return 69 again? Yeah. Yeah. I want to check the assembly. I figured. No boxes. You move the literal 69 into a register and move on with your life. One instruction. That's it. No memory. Nothing like that. Loads in immediate. Eletri, yes, but we're not going to get into that. You can look up malloc and free. Like literally just Google malloc and free, and there's a million resources on how that works. Just Chill says, so I get it. Hey, that might be the best message I've ever received. So I get it. I love that. It's like the return is a special box and you put 69 in it. It's right. That's exactly right. You've said it perfectly. And this, okay. So if in memory there are boxes that you put things in and can get things out of, registers are a lot like boxes as well, except they have identifiers instead of numbers, right? So you don't have register 0, 1, 2, 3, 4, 5. You have EAX, EBX. Technically now you have RAX, RBX, RCX, RDX, RDI, RSI, RSP, RBP, R8, R9, R10, R11, R12, R13, R14, and R15. You have all of those in x86 64. Yeah? So all of those are like special boxes that are all the same size. It's like a shoebox. It's not very big, but you can fit stuff in there. Yeah? And if you wanted to store like 4 shoeboxes worth of stuff, you'd have to take it one shoebox at a time and move it into memory. Saraid says local variables are on the stack, but if you have a pointer, then there's generally no way of knowing ahead of time where the thing it points to actually is. Well, you say that, Saraid. There actually is a way to tell if something's a stack pointer per OS. But it is doable because the stack is usually virtually mapped to the same address space in every process, which means that stack addresses are always in the same range. Or they can be if the OS chooses to implement it like that. Eletri says, oh, they allocate void pointer, which is casted. Yep. Just Chill says, I'll commit to this stream, though. I like it. Thank you. Thank you so much, Just Chill. I appreciate that a lot. There are links all over the place if you want to figure out how to do things. Down below, there's a YouTube link, Discord. Feel free to join the Discord. We'd love to have you. Stuff like that. Gent says, hey, I'm learning too. Just Chill says, we are. Yeah, you need that meme. We are. We are learning. We. Okay. CalcMath says, C is like Rust's great-granduncle, so it can do all the basic stuff. It can do way more than Rust. Eletri says, C is everyone's uncle, lol. Exactly. GentTV, lol. Saraid says, ahead of time, as in if you have a function parameter, you don't know where the thing that gets passed in is without inspecting the pointer value. Ah, this is as opposed to Rust box type, which, as I understand it, is always on the heap. I understand what you're saying now. Do you know that's actually the biggest misstep in C history, is what people think? That's the issue. CalcMath, the other day I learned about sbreak and map, which is what malloc uses internally. It was very interesting. Legendary. No way! Okay, there's no message, so I'm not going to say a name because I don't want to dox anybody. But I will say initials. Thank you so much, AF, for donating. We got that $10 donation, that clean 1080. Man, you're doing the resolution of the stream. Look at you. Thank you so much, AF, for donating. I don't know who that was. Hopefully, if that was... who said I was going to support this? I'll commit to this stream. If anybody wants to claim the donation, I'll trust you. You can get the glory. Thank you so much to AF for donating to the stream. It matters so much to me that that happens, and we are on our way to doing this actually all the time and not having to justify it as a great time waste, right? Just Chill says, can we check trees? I don't know what that means, but yes, sure. Is a null void pointer just zero filled? What is null? Okay, 2 questions that are the same. Perfect. Hopefully that L value-ness makes sense. If anybody has questions, let me know. So I'm pretty sure that I can expand this macro. Look, so I'm asking my code server, can you expand this macro, right? Okay, it got expanded. So null is literally hashtag defined as this. This is null. It's a void, it's a 0 cast to a void pointer. That's literally all it is. It's just null. That's what null equals. You can see at the bottom, it even tells me. That's what it is. Just 0. AnnOSRS says, look closely at my name, it will click. Hold on, I gotta look. Yeah, that does make sense. See, I'm not smart. Thank you so much, AnnOSRS. You are a legend. AnnOSRS, the most recent contributor to the channel. Everyone give him some love. We love AnnOSRS around here. Give them some love. Okay. CalcMath says it's the 0 address. Like index 0, I guess, in your example. Yep. That's exactly what it is. It is exactly equal to index 0 in my example. Aw, AnnOSRS, you're so sweet. You're welcome. Thanks for explaining pointers. Anytime, any questions you have, I'm here. Roosterhead, Gabe's Inferno, Shaky Noodle, AnnOSRS, Altity, I am Stevo, ooh, Arilax, and Arata Omori. Thank you. I don't know how to say that. Thank you everybody so much for following. I cannot believe we're doing so well today and that we have had such a fun time. I've had an amazing time. I'm glad I could be educational and help some people learn some of the more complex parts of C, where you have to say pointers and what is actually a pointer and how can you access the pointer, what the pointer points to, and how can you access what the actual value of the pointer is, and what is the value of the pointer, and what is a pointer. Right? It's like, So it's just an L value with value 0. AnnOSRS? Yeah, you're pretty much correct. AnnOSRS says, what do you mean? I may have missed something. Oh, CalcMath asked, wait, you are actually going through KNR in your streams? Like, Dennis Kernahan, or Dennis Ritchie and Brian Kernahan. I said those backwards. Brian Kernahan and Dennis Ritchie, aka KNR, they basically created C. So he's saying you're basically going through the creation of C with these streams. Maybe I'm incorrect, but that's what I'm pretty sure that meant. Just Chill, what is a void pointer and what's special about it? Void pointers didn't exist for a long time. Didn't exist for a long time. People use char pointer. Yeah? That's just, let's get that history out of the way. AnnOSRS says, that's from years ago. I have tried and failed many a time. Oh, okay, Cantel, sorry. Void pointer didn't exist for a long time. People use char pointer. But what did they use char pointer for instead of void pointer, right? What is void pointer used for? Void pointer is a memory address to no particular thing. Int pointer is a memory address to an int. That's the basics. AnnOSRS says, no, it's cool. I completely forgot about it. That must have been from before I graduated college, mid-2010s. Legendary. That was like 8-10 years ago. Void pointer is a memory address to no particular thing. Int pointer is a memory address to an int. A void pointer cannot be dereferenced. Void has no value. It's actually the absence of a value. How do I spell absence? Did I do that right? I don't feel like I spelled absence right. That's better. A void pointer cannot be dereferenced. Void has no value. It's actually the absence of a value. Yeah? But it's like placeholder value when you don't want it to point to anything. Let's give a real example. We have a struct foo, right? And let's say it has an int n in it or whatever. Void means returns nothing in C#. It's exactly that, because it means the absence of a value. There is nothing there. It returns nothing. Yeah? So you have some struct foo, which is n. And then you have some struct foobar, which is actually some struct foo f, right? And then an int x. Yeah? Foo, foobar. Now we can create a, right? A foo a. And then we can create foobar b. Oh no, structs, I don't know what those are. Seriously? You've got a lot to learn. I'm not teaching you what structs are. They're very simple. You can definitely learn that one on your own. And it's a good challenge to make sure that you can teach yourself. So you can have struct A and B, and they're different, right? They're different. However, if you want to allocate something, let's say, you want to allocate a struct foo, my foo, then you could do this. So you can create a foo pointer, my foo, which is equal to malloc size of struct foo. And this gets into one advantage of void pointer. A void pointer is a memory address that can be cast to any other pointer. I mean, any other pointer can be cast to any other pointer. But there doesn't need to be anything, right? Malloc can return any amount of memory, any pointer, anything, and we just say, now it's a foo. Right? So malloc returns a void pointer, and we can cast it implicitly to a foo pointer, and then treat the underlying memory as my foo. And what you can think of this as is malloc returns some byte array index, like 2, right? Remember, foo was at byte array index 2 before. Casting to a particular pointer type lets the memory at index 2 be treated as an object of that type, of the base type. Yeah? Which can be seen here as we have my foo returned from made from a void pointer, right? So my foo n can equal to 42. You can take this pointer, which is the same as this, by the way. in case you're curious. So you can dereference my foo to get a foo, and then you can access the member n within it, and then you can see assign that to 42. Can you use this tool to explain it? No. Yeah, but I get the confusion. Void pointers is a weird misuse of the void type in C. I guess the way to think about it is the type void is completely different from void pointer. At least that's how I understand it. Sorta. They're very related. Void pointer foo is equal to 42, right? You can do that. But then what happens when you dereference foo? Well, it will take the size of void and whatever is at address 42 size of void, it will give you that, right? But the void being a lack of a value, right? When you dereference it, you'll end up with a void, right? You'll end up just with void. So there's no actual value here. You can do it. There's just, you don't get any value. The size of void is 0. So if you read 0 bytes at address 42, you get 0 bytes in return. You get nothing, right? However, you can also say an int pointer is equal to foo with a cast, or not, because of the malloc thing, right? And then pointer bar, this actually gets you an int. So pointer bar equals an int, but pointer foo is a void, nothing. This is a number. And you can see that the pointer has not changed. 42 is still the value of the pointer. However, the underlying data that we're treating it as has become an integer, which is 4 bytes instead of a void, which is 0. Yeah, void as a type in general is semantically a bit strange in C. Yep, you actually, Just Chill says, what if you print the value of foo? Well, you'd get 42. This is what it is. It's 42. You should try it, though. Go to Godbolt. Make a point, right? Make something. And then print it. I guess you have to know printf a little bit, but you can do it, I promise. Nothing too complicated here. There you go. Here's the address of foo in a real world, right? The program returns 69. The address of foo is OX7FFDF740B768. You can also print the integer at foo by dereferencing, right? And you get 69. So this is the byte array index, and this is the 4 bytes, the value of the 4 bytes after it. Coolio? It only really exists because the grammar requires it. Yeah, there's no reason void pointer couldn't just be like address. You could also just call it address foo and then have it be anything, right? So foo is just an address. That's all that matters, right? 42 is now an address. Foo equals to 42 as an address. Foo is an int pointer, which means that we will treat the address 42 as an int. Hopefully that makes sense. An address doesn't necessarily have any object at it, but a pointer does have an object at it. But yeah, if you think of void as the absence of a value, the absence of a value, right? Not void. Void. Yeah? So if we went back to our little model, this is foo. This is bar. Right? We have a void pointer foo equal to 42. We have an int pointer bar, which points to the same spot, right? It points to the same spot that foo points to. Because foo is somewhere in memory and then has this as its value, right? Foo equals 0. Bar is equal to 0 as well, but just because there's all zeros here. Does this make any sense? An int pointer is 4 bytes long and has a start. A void pointer is 0 bytes long and has a start, an address. Hopefully that makes any sense. Void is just the absence of a value. That's all it means. Nothing more complicated than that. It means nothing is here. How much memory pointer to int allocates? Well, any pointer will be the size of your architecture. How a pointer is 0 bytes long? I didn't say that. I didn't say the pointer is 0 bytes long. I said it points to something that is 0 bytes long. A void. Void is 0 bytes long. Int, 4 bytes. Yeah? The size of a pointer is equal to the size of any pointer, which is equal to 8 bytes on x86-64. It's an 8-byte number. This pointer is large, yeah? It's 8 bytes. But the value at that pointer can be 0 bytes long. Because you can have a byte array index, right? Byte array index 4 through 4. 4 through 4 means nothing, 0, right? 4 through 5 would be like 4 and just 4, right? This is byte array 4. You don't need anything to say, hey, the next 4 bytes are an integer. It just says, this is the byte I'm talking about. Byte index 4. And this is the value of a pointer. And this is stored in memory, yes, somewhere else, which is complicated because you have 8 bytes, which then just has a 4 in it. Cool? Cool. Hopefully any of that was educational. I gotta go. I don't get it though. How do we have a memory that points to nothing? I don't know how it's confusing. You have a start, which is your address, and you have a length, which can be anything. Size of type. Yeah? So you have some int foo. You have an int pointer, which equals address of foo. But then you can say, I have a void pointer, which is also equal to the address of foo. The same value is stored in both of these pointers. Let's in fact take this to Godbolt and print it out for you. Then we're going to say int pointer. Does this make sense? an int pointer and a void pointer how does the void pointer get allocated? Just like an int would be. Remember when we were going through and we had bar and we created bar? You just create another thing. You say, this is our void putter, right? It starts here. And it starts here and goes all the way through these 8 bytes. It can, and then it's equal to this value, right? It's 7f, ff, 08, 00, 08, 88, 0. It's actually like this, it looks like. There you go. Here's your void putter. This is what it's stored like. And that stores the actual address here, which is like something like foo. Make sense? Size of void pointer equals 8. Size of void equals 0. Size of int pointer equals 8. Size of int equals 4. These are different, right? The pointer itself gets stored in 8 bytes anywhere on the stack because it's a local. I think I get it, but I don't get why we might need them. That is perfect, because I haven't explained why we might need them very accurately. But there's a lot of reasons. Like, what if you had a node struct, and it has an int type, and then it has a void pointer data? Then you could say, if my node.type is equal to 0, or like node type function, then you can cast data to be function data pointer fdata, which equals my node.data cast to a function data. Just Chill says it's always 8 bytes. Well, yeah, pointers are always 8 bytes because x86-64 is an 8-byte architecture and the maximum memory addressable is like 57 bits, which is 8 bytes. It's not always 8, but on this architecture, yes, it's always 8. And then you could say, if my node.type is equal to node type integer, then int pointer int data is equal to int pointer my node.data. Hopefully that makes any sense. This is why you might need a void pointer, so that you can have a single struct contain an address, but it may be an address to a function data, it may be an address to an int, it may be an address to anything. Yep, all of them are the same length. Whew. Gent TV says, I get it. Aw, yay. I'm so glad. Oh man, it's so late. When did it become 6:40? Oh god, I'm so screwed. Did seriously like 2 hours just go by in like an instant? That's insanity. It's 4:40 a.m. for me. Oof, I'm sorry, Gent. I can't believe you're learning this at 4:40 a.m. Calc math, good job, Mr. Strimmer. How does it differentiate the type of value it points to? The compiler keeps track of that at compile time, but in the final binary, it isn't kept track of it all. Oh, thanks, Gent. You're that interesting, buddy. Oh, I love you. What can we not do anymore? Came to watch something while video games updated. Stayed for sea knowledge. Legendary. Legendary, AnnOSRS. Hopefully any of that makes sense. Yeah, hopefully. Stroid says, we can't do this anymore. I posted this. Oh, God. Yeah. That might be... Oh, God. Seeing S-break in here is terrifying. They linked that earlier. I see. In one line of code. Stop using floats. You have played us for absolute fools. Stroid said, look at the first line. Programming war crimes. That's a Lisp interpreter. It might be. I can't believe S-break. Define D, define. Why? Why would this even happen? That's so crazy. I love the percentage A and percentage D. Or not percentage, hash. Hash D and hash A for no reason. Like, you could just use define and include, but no. Gotta make it as confusing as possible. Define P, char pointer. Define P, comma, P. Define T of E as not string compare E. This doesn't even... None of this makes sense. Why would this happen? This is so bad. Bruh. Bruh. This is incredible. I love the spaces just for fun. Lisp. Obfuscated Lisp. That's pretty crazy. That is pretty crazy what they've done here. I don't even know what I'm looking at. I de-obfuscated it as a project. Lisp is pretty cool, actually. It is, it is. Wait, does this code even work? It might, I don't know. I mean, there's an easy way to try it, I promise. It doesn't work. Only because of these. I think you could still do it. You just have to replace all the D's with define because you can no longer replace a preprocessor directive with a preprocessor definition. There's probably a better way to do this. Well, I can't type on this keyboard sometimes. Pog. It works. It did something. It wants me to include standard lib as well, by the way. Legendary. Beautiful stuff. Data definition has no type or storage class. That's so cursed. It's using implicit int, isn't it? That's what it is. CalcMath says, after you inline the define macros, because that's what you can't do anymore, it gives you a REPL. I see. It did at some point. The syntax it uses is wild, actually. Oh, really? It looks pretty normal to me. It might be a little wild. I'm going to leave that in there so I find it sometime. Anyways, thank you everybody so much for watching. I am on my way out Everyone give love to AnnOSRS for being the most recent contributor to this channel. Helps me justify actually sitting here for 6 hours straight and doing this instead of working or doing something important with my life. Right? No, I just enjoy talking to you guys. I do it anyway. But it does help me able to spend more time on this instead of life stuff. Gotta love how main is recursive, lol. Yes, that's a little rough. CalcMath, thank you for stream. Gent TV, love you. I love you too, Gent. Thank you for coming out. Walker Codes, amazing stream. We'll be sure to tune in for future streams. Thank you. Be sure to check out the Discord to get announcements every time I go live. I will post it there, so be sure to keep up with that. Sarade says, ta-da. Aletri says, adios. Thank you, everybody, so much. I will see you so soon. And be sure to join the Discord and send a message. Come say hi. We love 69. So if you love 69 too, come be in our 69 group with our 69 dudes. Yeah? Cool. Hopefully that gets you. Anyways, Probable Steve, thank you so much for the follow. That's cursive as fuck, though. Cursive. I really like that. That's cursive instead of cursed. Anyways, thank you all so much for watching. I've had such a great time today. Be sure to check out the YouTube down below, the Discord, the GitHub, and Codeberg for all my most recent code and contributions. Go try out the compiler. You know what I mean? Compile an example and run it on your machine. It's fun. I promise. I don't think the IR works, but you can use it with literally anything else. And yeah, and I also have a ton of other stuff like an OS. I have an OS that I work on all the time. Go check that out. Check out my bootloader, the software floating point library I just wrote on stream. Check it all out. Check it all out. And most importantly, click that follow button. Go everywhere. Use your brain. Think exclusively and critically. And I believe in you. You'll get what you want done, I promise. Bye. Love you guys.